Hello. Hello, everyone. Welcome to JSConf Iceland 2018. I was a bit stressed that you might not be woken up yet, so I'm glad you had some coffee and tea in the morning. It was super nice to see many of you last night. We were getting a bit stressed over the weekend because of the storms that were hitting Iceland. But for some weird reason, we were one of the hottest countries in Europe yesterday. We did not expect that at all. Last year, at the exact same date, we had 50 centimeters of snowfall in one night. So I guess it all depends on luck. I'm not going to keep this long. I'm going to introduce all the organizers to the stage now. Welcome up. It's a handsome group of people. We are 11. Yeah, please give them a round of applause. So it's Stefán, Svanhvít, Benni, Axel, Siggi, Brian, Eiki is sitting over there, Eka, and Ragnar, and I'm Christian myself. So, yeah, we want to begin by thanking you for being here. It's awesome, like I said, that you all made it. It's hard to be an island in the nowhere, so we are really glad to get some clever people here and teach us locals how to do jazz, I guess. Our sponsors are awesome. We could not do this without them. Advania is the platinum sponsor this year. We're super thankful for them. Please give them a round of applause. They were also a platinum sponsor last year. We also have Cosmos and Chaos. So please some clapping. Twilio. Woo! Mozilla. Yay! Arantxa. And Landsbankinn, the National Bank of Iceland. And we have the bronze sponsors, Vuxi Nextcode, Hard Rock, which is the off-venue location. You can keep clapping, it's so much fun. NetApp, Origo, Ueno, CCP, Apress, and Icelandair. So I'm not going to keep this longer. I'm going to hand it over to the Code of Conduct team. They will take care of you if something comes up. Don't hesitate to reach out to us. We are always available. We're here for you. Reach out to us via any channel, and they're going to explain it more. Thanks.
Hello, my name is Benni, or just Ben. I, Svanhvít, and Raggi, we are basically the Code of Conduct team. And I want just to tell you a little bit about that. When you all bought a ticket, you agreed to the Code of Conduct, so I just wanted to remind everyone of that. The Code of Conduct applies to all the events we are doing, not just the conference, also the parties and the trips and stuff. So just keep that in mind. If something comes up, we have created a form for you to report it, or you can just come to any of the organizers and we can, and make a report. Sorry. So we also put up a phone number in case of anything happens. All the information should be on the website, jsconf.is. I think that is everything. Okay, thank you.
So we did something amazing this year. Last year, I always say last year for some weird reason, but 2016, last time we hosted JSConf, we had an awesome hack inside of Norðurljós, which is the hall next door. We hacked all the lights and people could interact with their API. That's the Wi-Fi. We decided to step it up a little bit this year, which is awesome, and Axel is going to explain what we did.
Thank you. First off, welcome everyone. I don't know if you know, but this conference hall or this building is called Harpa. It's one of our key conference halls, and it's the host of the symphony, the opera, and conferences like these. And it has won many design awards and other things, rightfully so. Just look around, it's beautiful. But one of the key features is that on the outside, and I don't know if some of you saw it last night, there are over 700 LED lights that light up during the evening. These lights are programmable, and all of us, me included, are proud to present that one of the speakers here today, Halldór and Þórður, they have actually programmed interactive light exercise or light fun activity thing that you can interact with in the evening and during the nighttime. And just to show you a quick demonstration, we have this video, or at least I thought we had a video.
It's on the wrong screen, sorry. Awkward moments.
I believe, Benny.
No! Sorry, it went full screen on my other screen. This is terrible. Yeah, okay. No sound.
So, like I said, I don't know, some of you might have seen it last night after the Hard Rock, that the harpa was yellow, it was blue, it was pink, and was changing colors all the time. So it's my great pleasure to introduce that you can now go to paint.jsconf.is now, and you can paint the harpa any color you like during the weekend. So please do it, please go during the evening, paint it, go to the website and interact with harpa. And also check out Haldur's and Þórður's lecture about it, of course, later today.
And yeah, you know the color which we are going to be using, right? Yellow, okay. Just to get that clear. Like, it would be pretty cool in the evening to, like, everyone take out their phone and just paint it yellow, like the whole evening. It would be super fun because we had some architect restrictions, but the power of the crowd can beat the, I don't know, suppressors. We have one more custom thing that we want to announce now. We got some custom beer that some of you got to taste last night. We have a really short making of video, and I'm going to hand it to the party team. Give them a round of applause.
Hi all. So we got the fantastic task of coming up with a theme for the parties. And during that process we discovered that the 1st of March is actually the Icelandic Beer Day. So of course we had to brew our own beer. We named it Bjór Jóðars, which is, we named it Bjór Jóðars, which is beer in Icelandic. So you all get that joke. Spoiled it. Sorry. We contacted a local brewery called Ægisgarður. This happens to be our venue for the evening, so you all get to go there and take a look around. We also have a short video of the making of the beer, so we just want to roll that now. Sure.
Thank you, Stefan. Although we created our own beer, it's not just about alcohol, and of course it's more of a networking event. Everyone is free to drink what they want, But we just wanted to emphasize it's a National Beer Day, so we thought that this would be fun. There is no pressure to drink, of course. Yeah, I think that concludes what we want to do now. Thank you, organizers, for coming to the stage. You can exit the stage now. And yeah, give them a round of applause. Fantastic group of people. Spent a lot of work doing this. Yeah, one thing Benny was just whispering into my ear, that the swag that we have is not for significant others. We're super sorry, but we have the exact amount of swag for the people that are attending. So we are probably going to give our away to try to give everyone some. And if there are any problems, you can just contact us and we will send it to your home if you don't manage to get some. So without further ado, I want to introduce our MCs. Yeah, I'm trying to see how awake you are. So yeah, they're going to take it from here. Welcome to JS Iceland. Enjoy.
Hi everyone, y'all are so quiet, but I'm so happy to be here. I just want to say thank you to my family and my partner who supported me through this journey. And it's been just wonderful, just getting here.
Yo, dude, what are you doing? We're supposed to go on stage together.
I'm doing my acceptance speech.
What acceptance?
Isn't this an award show?
Where's your award?
Shit.
We're MCing.
MC?
Yeah.
But I got dressed and all that.
Well, I mean, we'll just get on with the show then.
Oh, all right. Okay. Sweet. And welcome to, wait, where are we?
Iceland. We're in Iceland, goddammit.
Oh. Welcome to Iceland JS. Oh, JS Conf Iceland. And our slide works, which is wonderful. We want technical difficulties in the middle of the show.
It's a conference without technical difficulties.
Okay. We're really excited to be here. We have a great lineup of talks from people that you've heard of, people you haven't even heard of before. Is this not working?
Nope.
Oh, that's great. Let's just hang out here then. Oh, no,
That's
it's
okay.
all right.
What's a tech conference without technical
Yeah,
difficulties?
what's a technical
really?
conference without technical difficulties? Am I right?
All right, so my name is Vanessa. I'm going to be one of your MC today.
And my name is Florida, and I'm going to be also your MC today.
We have a lot of people here around the world joining us today. Just going to quickly go through some countries that we have here.
Don't you want to plug our social media first to be Twitter famous?
Yes.
I'm just going to leave this here and talk a little bit. So Twitter, it's a great platform to follow people. To follow people.
Oh, really?
To follow people.
I have
I'm just
not
going
heard
to keep
of
saying that until I get notifications in my phone and someone follows me. Okay, now that we get that. Shout out to Canada, we're actually both Canadian.
Yep, we're both Canadians taking over Iceland. What up?
I finally got notifications on my phone. Anyway, we do have a lot of people coming from different countries joining us today in, this event. People from Canada, people from the US. People from the US are so quiet. I'm also from the US. Woo! People from India, from Nepal, the UK, Germany, Netherlands. People are so quiet. Where's people from Iceland? People from Iceland? Oh, there you go. That's where our crowd is from. People from the Netherlands, Stockholm, Portugal, Croatia. Oh, see, they're louder. Awesome.
So what else? Tel Aviv, Australia. Oh, wow, Australia. How long did that flight take you? Mexico, Finland, Norway, Poland, Ukraine, Russia. Did we miss anyone? Denmark. All right.
Ooh.
Okay.
What else did we miss?
Speak now or forever hold your silence.
Yes.
All right. Okay, we got all the countries in the world.
Awesome. So a quick PSA. for everyone. People tend to mix me and Vanessa up. I don't know why. It's not like we're matching, or it's not like we're like similar heights. It's not like we do our hair the same way. I don't know why people keep on mixing
I
us
have no
up.
idea. Greatest mystery. of all
Yeah.
times.
So here's me. I prefer to be more handsome than Vanessa, and I also use they them as pronouns. So, and I also have a nose ring. And these glasses don't work. They're just here so that I can look smart, so that I can blend in with people today. And then Vanessa.
Oh, yes, me. That's me. Yeah, I use she, her. Apparently, my eyebrows are always good. And if you're still confused, I most of the time have some over-the-top earrings on. So that should be easy. Okay, I think we have a few housekeeping items. So first off, we have a Slack channel. If you're not already on it, it's slack.jscom.is. Please go join. You can get a lot of info and cool people to hang out with.
And also, we have Björtoloft in the 5th floor. There's a coder workshop for kids happening already that will run until 12:20. There's also a diversity panel later for our nice lunch around 12:50. And also, Vanessa, what do you think about the weather in Iceland so far?
We're talking about weather? Really? Okay. Weather has been all right. Could be better.
Oh, yeah, but we do have swag from Zoan that's in the booth that will give us free swag, such as jackets and winter gear as well. And they also give out 30% discount for everyone.
And it's just today, so don't miss it.
Also, another thing, apparently there's electricities under your tables. Don't be alarmed, it's not to shock everyone. But it is for your laptops and like plugs and all that. Apparently they're still working on that, but it will be all good later.
So for today, we will first have 2 keynotes, and then we're going to split up this court into 2 tracks, Hekla and Katla. I hope I'm saying this right. And then we have 3 more keynotes and panel end of day tomorrow. Talks are going to be 30 minutes per talk, no questions from the floor. That's it.
Sweet. Everyone's been super quiet. I want to test how everyone reacts to memes. Let's see. This is just a test. Okay, so no sarcasm. No sarcasm.
All right,
Puns work. Looks like
yeah.
puns work. Dry humor. No, not into.
Sorta.
A little bit into dry humor. A little bit.
Yeah.
Okay,
everyone
good,
likes
good
animal.
reaction for animals.
Yep.
People enjoy animal suffering.
Okay, yeah, this is what I'm getting.
Okay, so it looks like a little bit of puns, a little bit of dry humor,
A lot of animal suffering.
a lot of animal suffering.
Okay.
This
Great crowd.
conference does not harm animals. And I mean, should we go on with the show
Yeah.
right now? Go on with the show. Woo! Everyone's really quiet. I feel like everyone needs to wake up and do some stretches and jumping jacks so that you make a little bit of sound. Dan over there is the great example. Power poses.
Yes.
Anyway, let's get on with our next speaker, shall we? Our next speaker is coming from Berlin. She's been a really active contributor to Node. She's currently pursuing a master's degree. And she's going to be talking to us about Node.
Yeah. Let's give it up for Anna.
Anna Hensingen.
Henningsen.
Henningsen. Hi.
slides online if something doesn't work, but.
Just gonna back up.
I'm not sure. I kind of feel like something froze here. It's mirror, right? Okay, yeah.
Automatically. It's supposed to be on automatically, but the magic's not working. You should be good. No?
Is my mic still? Oh, my mic's still on.
Oh, that's yeah, cool. Okay, great that that works now. I think like there's like a tiny bit of the screen that's cut off at both ends. I don't think it's going to be a problem. Just like, yeah, just tell me if something's completely not understandable. Yeah. Anyway, I'm Anna. I don't know like whether you're all morning people. I'm not. I'm not usually awake at that kind of time. So yeah, I hope this is going well. It's not going to be it's going to be a technical talk about Node. Just like, yeah. Okay, so first of all, like the forward key doesn't work here, so I'm gonna have to go here. Okay, so who am I? I'm Anna. I'm ADDALEAX on Twitter and GitHub. Pronounce it whatever you want. I use she, her pronouns. And I've been an active contributor to Node.js since December 2015, so like quite a while ago. And I'm on the Node.js TSC, like technical steering committee, and what that means is that I am one of the people who, like if there is no consensus among the Node.js collaborator group, we're the people who decide what actually happens or who try to set the general direction for where the project is going. Like that also means that like if you want to complain about something or anything, you can, like I'm a person you can come to. And yes, like I'm going to start this talk by like describing how I originally got into coding in Node.js, contributing to Node.js itself. And so like there's this, I hope can you all read that? Not so much? Okay. So like basically it's like setting, using set timeout with like invalid parameters, using the, like accidentally passing a number twice, and like don't ask me why I did that. I had something like that in my code once, and like I couldn't really figure out where in that code that was. Because like that was the original stack trace that you were getting, and I still think you're getting it on Node 4. And so yeah, just like it's blowing up when it tries to call that function, which is 1000, which is not a function, so it's not going to work. And so like, yeah, that was frustrating to debug, and actually the easiest way that I could think of debugging this was like to actually patch Node core so that it would like throw an error if the function for set timeout is not actually a function. So like this is, I mean, there were tests and there was the documentation change and everything like with this, but basically this was all the patch there was. Like, if the callback is not a function, then like complain immediately. So you would get a proper stack trace, and Yeah. And like I'm mentioning this because like it shows that Node.js is part of your application if you build something in Node. So it means like every improvement that you make to Node makes your code better. And like if there is something that you think that Node could do better, you can like try to come up with a pull request or maybe even just open an issue or something. It's a lot of these small things that actually make Node a great software. So like for example, like of the like 7 or 8 last pull requests that I opened, like 2 were actual bug fixes for like HTTP2 stuff, and like 5 of them were just like stuff that I ran along the way while I was debugging them. Just like thinking, okay, yeah, this is not helpful what Node does there, so let's do something more helpful. Okay, yeah, so why was I talking about that, and like why I'm talking about Node.js in general? It's not just because like I'm a core contributor. It's also because like before I made that patch and like before or later I started watching the Node.js Node repository and everything. I didn't really have a lot of concept about what was going on inside the core Node.js community. It was kind of like its own separate world. And I know that a lot of people in the community still feel kind of disconnected from what's happening there. Like most of you probably just like take the releases of Node as they come and like update every once in a while, and sometimes hear about new cool features or something. But basically that's it. And like I think it would be cool for both sides if people had more of an idea what was happening in Node, and if we Node core people had more of an idea what users actually do and need. I mean, like it's not like none of us aren't users either, but you know. Okay, so and where are we now with Node? So like Node 10 is just around the corner. It's probably going to come out in April. Until yesterday, I thought it was definitely coming out in April, but. Okay, yeah, so I'm gonna like maybe mention that later, but yeah, probably. So like what's coming out? It's features like ES modules, which yeah, don't be excited like too early. It's like I probably can't speak as much to it as I should because like I try to stay away from that topic because like it's not like healthy to like talk about it a lot. HTTP2, which is like a lot more fun, and which like I'm participating in a lot more. Async hooks, which you may have heard of, might probably not have used. But like it's a pretty cool thing, and people are building pretty cool things with it. And yeah, you're gonna want to know about that. An API, which is like also very, very specific. It's just like for native add-on authors, but it's a cool new thing in Node. Then there are like things that move along with JS, like as JS evolves, or things that we see in the web platform in browsers that we think, yeah, that might be cool to have for Node, like standard URL object. Like it's I think it's becoming a global in Node 10. So like you can just like take URL, new URL, just like you write it in the browser and use that same thing in Node. Text decoder, text encoder, those things. Then there's things that are coming from the JavaScript engines themselves. Like we are currently in master, and so probably in Node 10 as well, on V8 6.4, which means like stuff like we have full WebAssembly support in there. That's pretty cool. We have I don't know if you've ever heard of that, but like the old debugger away API, that went completely away. But we also since then we introduced as a replacement a way to talk you can talk to Node like the V8 Chrome debugger. Like you probably have used that with Node, or I've heard that you can do that. It's like there's an API for talking to Node with that. So like you can actually do really cool things. Like inspect the actual stack of your program while it is running, and not just the stack trace, but like the actual variables and everything. It's like pretty cool stuff that you can build with that. We're changing the error system in Node. Yeah, I'm gonna like have more details on everything in here later. So, yeah. And like some more longer term efforts. Yeah. Okay, so ES modules. I'm just like gonna give an overview of where, like my understanding of where we are at this, and I think my understanding is pretty accurate. But I'm not like like 2 or 3 weeks ago we spun up a new modules working group. And so like if you're really, really interested in like knowing what exactly is being discussed and is happening, you can, like they have meetings and they are being recorded, and you might want to check those out. There is experimental support in Node, so like you can run Node -- experimental modules, I think, something like that. And you actually can use ESM with that. It's not quite where you want it to be yet. So like one of the things that that we're currently having in Node is that .mjs is happening as the file extension for ES modules. That might not have to be the end of it. There might be a way to like use ESM with .js files. We're just like gonna have to see what we can make happen, what like is actually best for everyone. Because like one of the things about ES modules is that in every discussion there's always like multiple approaches, and like none is perfect, and like it always has real downsides for everyone, and like I can't go into detail, mostly because like some of those thoughts like for example, one of the things that I have here in the list is that named imports for CJS, for CommonJS. So like you write a module that's called like leftpad or something, and so you want to like import and then import the actual function. I don't know what it's called. Import pad from from leftpad or something like that. It's not like going to be what you. It might work, it might not work, and like. It's not as easy as saying, okay, yeah, we can just make it work. It's tricky. It's also going to be very different from what you have right now with CommonJS, because like it's being loaded asynchronously. So like that's one of the issues that we have like with interoperability. So like you can't just require an ES module that's like never going to actually work, because require always gives you a synchronous result, and that is just like not happening with ES modules by design. It's also not going to work like Babel like currently compiles ES modules. It's like probably one of the more tricky things to work around. It might be good enough, but like Babel isn't doing it like the spec wants us to. So like we're going to have to do it like the actual JS spec wants us to do it. So yeah. Okay, so like just like to give a quick overview. So like import fs from fs, just like importing the entire module, that is going to work. That currently does work. We like for core modules, we're also going to have named imports in some way, like most likely, because like at least there are ways that we can make it happen. So yeah. And importing like between userland ES modules is always going to work. Like that's just like completely spec'd, and yeah, that's not going to be an issue. What we are not going to have in ES modules is __ file name or __ dir name, something like that. Instead, you're going to get the URL of the current module, and all of that lives under import.meta. So like, there's no magic globals like or pseudo globals like require or module or exports or anything like that. And you're probably going to get like import.meta.require, which like is going to give you a way to at least load existing CommonJS modules in ESM. Okay, another thing, HTTP2, which is like as I said, it's something that I've been working on a lot more than ESM. And it's really cool. We have like pretty much everything in the API fleshed out right now, so that's nice. It's currently experimental. It has been since it was introduced in, I think, 1.5 years ago. I don't remember exactly. But it's like, the hope is that in Node 10, which is like 1 month away, it's not going to be experimental anymore, mostly because like the API is really fleshed out at this point. It's a lot like there is a compatibility API, so you can use it a lot like HTTP1 or the existing HTTP module if you want to. That's going to be useful a lot of the time. You can actually, like, at least if you're using TLS servers, you can actually build servers that support both natively, which is really nice. But like the new API that you get from HTTP2, if you don't care about like the old stuff about HTTP1, it's a lot cleaner than what we have in HTTP1. Yeah, it's just like, it's also just like better code. Like HTTP1 was like written in a time when Node was a lot smaller, and it was just like, there was less commit review. And more like, okay, yeah, we're gonna like make changes, and like if something breaks, then we're gonna fix it. Yeah, so it was a different time. And plus, you get all the perks of HTTP2, which like you can have a single connection and multiplex different streams, so like basically different files over that. You get push streams. It's like, I'm not exactly sure like how people are actually going to use it, but I'm pretty sure that they're going to build amazing stuff with it. And so like this is a basic example of like how an HTTP server looks like. You're going to see that like this is not the compatibility API. This is like the actual new one. And you're going to see, okay, some things are pretty familiar, like creating a server and listening on a port that works like you'd expect it to. But instead of like requests, you get streams. It's like kind of conceptually the same thing. It's like an HTTP2 stream. It's like an actual writable stream that you can just send data to, and instead of like writing headers, you respond with headers. Like, conceptually, those are kind of similar, but like you can yeah, it's just like pretty similar if you look at that, but like it has a much richer API, but you're gonna have to look at it up in the documentation if you actually want to know a lot about that. Okay, so one of the things that I also find pretty cool in Node is async hooks. And that's a way to like get more of an idea of what is currently happening in Node's event loop, like what things are keeping the event loop alive and what things are currently running. So like, for example, if you're reading a file, you could actually use async hooks to tell what file requests are currently going on. It's also a API that allows you to like keep track of what async thing is causing what async thing. So like, for example, some people have previously built stuff like continuation local storage with the previous thing that we had for it, which was domains, which is like not a great API. It's like why we're getting rid of it. And that basically means, okay, for example, you can keep track of where your current code is, like to which HTTP request it originally belonged to, and like just like keep track of that and see which where that originally came from. And you can use it for like diagnostics, for looking at the timing of operations. It's still experimental and it has a lot of rough edges in its API. I'm going to give an example like pretty much right now. And just so you know, if you're writing add-ons, native add-ons, like Node doesn't automatically know what you're doing. Like if you're just like calling back from C++ or from C, you're just like Node doesn't know where that originally was caused in Node, in the JS code. So like as a native add-on author, you're going to have to support it like pretty much explicitly. Okay, and so this is like one example script. So like async hooks, that means you have 4 hooks. It means like you get an init hook, a before, after, and destroy hook, which is like keeping track of like every single async operation that is happening for like sockets. So like if there's an inbound connection, the init hook is called. Every time there is an event on that socket, the before and after hooks are called. And like once that socket closes, it gets a destroy hook that is being called. So like I have like reading the current file as an example here at the end of the script. And so like what that actually does is, okay, so the first thing, it's initializing a FS request grab that gets the ID. What is that? Oh, it's the ID 6. It's like numerical IDs that you're using to keep track of everything. Then later in that script, the before hook is called, which means that that request is finished. Then it's initializing another file system request, gets the next ID, which is 7, and then the original one is finished, like it's after and destroy hooks are called. Then later, the same thing for the next request, like it's finished. It calls its callback, which is like indicated by having a before and a after hook. And because it's a request, like request means it only, like it's when it's finished, it's done, it's always getting called, it's calling the destroy hook. And finally, you get another file system request. And so like, this is just like the beginning. So like, it's very, very detailed. Well, what you can actually see is that there are different things happening here. So like, the first is actually opening the file. The second one is actually reading from the file. And the third one is closing the file request. So like, it's very, very low level and very detailed, but yeah, you can build pretty cool stuff with it. One of the things that are also like in the area of things that are pretty cool in the web platform and where having compatibility is nice is Perfhooks, performance hooks. It's also like, I think it's introduced in Node 8, and I think it's still experimental too, but like also slowly getting out of that. I might be right, might be stable by now. And yeah, this is just like the performance API, like you have it in the browser if you ever have come in touch with that. It's like you have performance.now and a lot more in there, like support for Node.js specific events, like you can actually tell like how long it took to load the main module of your application and everything. And it gives you like low overhead timers, which is like, we have something similar with like console.time and console.timeend, but yeah, this is the cool new stuff. Okay, an API. Who in this room has ever written a native add-on with Node? It's not a lot of people. So like if you ever like felt that that might be useful for you, this is a cool new thing that also makes that a lot easier. It's like if you previously wrote an add-on for Node, you had to understand the V8 API, which is doable but really, really tricky because like if you're coming from a JS background, their error handling is just like going to be really, really confusing. Because like it's written in C++ and they don't use exceptions because like that has performance impact. So they're going to have to do something really, really tricky. And with an API, you have something pretty natural. So like this is an example of how to write a C++ add-on with an API. This is just a single function that you can expose to JavaScript. And I mean, it's not quite like JavaScript. You still have like to do things like explicitly convert, like say this value converted to a number and then like give me the value as a 32-bit integer. That's overhead you're not going to get around. But like it's like as a JavaScript developer, you can definitely understand what this does and make changes to it. And yeah, it's doable. Okay, another thing, promise support is just like something that we're going to live with. Like, there are people who don't really like to use promises in Node, and like they're going to keep being able to do that. But like generally, people are going to use async await, people are going to use promises for a lot of stuff. And yeah, as a platform, Node just like has to move along with that. And so like we have, like if you don't use async await at this point, you should. Just like telling you this is just like really, really, really nice. We have await support in the REPL by now. I think that's also just like coming out in Node 10, because like we actually have to like do some weird transpilation inside the REPL. Like previously didn't do that, but we think it's worth it. So like we have to ship an actual like parsing library with Node. We have util.promissify in Node 8 and above, which is like the bare minimum. Like you can convert Node functions to like promise APIs, but it's just like you still have to do that explicit conversion, which is not that nice. We have a new module, fs/promises, coming in Node 10. And that is actually going to be like all the file system functions that you're used to, except they work promise-based. And like instead of file descriptors, like you're working with, like if you're using file descriptors in the current file system API, you're working with the actual raw numbers, which is like not that nice, because like, I mean, you can open a file and basically forget to close it, and just like, it's going to leak resources if you are not really, really careful. Like if something throws before you can close the file descriptor, you're gonna have a resource leak. So like there's, the one change that is different from the normal FS API is that you don't actually work with the raw file descriptors, you work with wrappers. And like if they get garbage collected, they're gonna show you a warning. It's like, hey, you forgot to close this. It's like, that's also pretty nice. And async iterators, which is like something that I think is like, you don't need a flag for it in Node 10 anymore, like just to have the engine expose those. And like we're going to implement that in some way for readline and for streams. So like you can actually do something like for async const chunk of stream instead of like listening to the data event of a stream. Also like really, really cool. And so like, yeah, I mentioned in the beginning that there were changes to our error system. And so like every error in Node is going to eventually have a error code associated with it in some way. This is usually going to look something like this. Like this is just like a very simple example, because like passing in a just like invalid thing to a function, like you can't listen on an array with a network server. It's just like going to tell you, okay, yeah, that is not the right format. We don't understand that. And it's like, so you can use, you can look up the error code on that error. And yeah, and that also means like, if you're currently like, the motivation for this is that like a lot of people were checking the error text, the error message, when they like to figure out what actually happened and just like do like diagnostics in terms of that. And that's not really cool, because that means that changing an error message is actually a Semver major change, or has been up until now. And we really don't want to do that. We want to like just like give you the best error messages we can. So like, yeah, if you want to know what was happening with a certain error, just use error.code from now. But like also like introducing this is always a Semver major change, or at least we consider it one. Just like to be careful at this point. So this is just like more of a long-term thing too. And yeah. Okay, workers. It's like there was a fork of Node that you may have heard of like a while ago, like half a year or so. And in there, I actually built worker support for Node. And I mean, that fork kind of stalled at this point. But I have a lot of free time in the next couple of weeks. And I definitely want to have this in Node. I'm going to try to like take the parts, which is like half a year old. So like, I mean, those are pretty big patches. But like, I definitely want to have that in Node and like want to get them parted and want to make that happen really soon. So like that is what the API would currently look like if those patches were accepted as they currently are. It's like completely up for debate, but yeah, you could just like have workers in Node, and those would have like access to the full Node.js API. It's not like web workers where you like have only a restricted subset of things. If you want that, you can probably build it with this. Yeah, but like this is like speculative. So like there isn't even an open pull request. So like take it with a like grain of salt. Are you all tired at this point? It's just like I know this is a very technical talk. It's like doesn't really have any highlights or anything. I hope you're fine with that. I mean, like the general idea is just like to give you an overview over what's happening. And I mean, if you want to like look something up again, you can always like take a look at these slides later, or ask me or anything. But just like don't feel like you have to like soak everything up. It's just like no. Okay, WebAssembly is there, which you have probably heard of because like over the last 2 months or so, like everybody has been really, really excited about being able to use WebAssembly in JavaScript. It's like, yay, we have support for that. It's not gonna like completely replace native add-ons, but it's going to replace a lot of the use cases that we have for those. Yeah, also like since Node 8, I guess a lot of people here that are using Node in production are still on Node 6 or something like that. Node 8 has a completely new compiler toolchain, which is like, I think like people were seeing up to 50% increases in performance just like from having this new JavaScript compiler toolchain. Like, yay. Great work that they did there. Like I said, the debugger API, if you ever use that, it's like gone because like V8 removed that, so like we can't provide it anymore. We're gonna have to live with what's coming upstream. Oh yeah, right. It's we also like managed like it's not really us, but like V8 decided to put Node in its own CI. So like that means that every change to V8 is actually being run against Node and see whether it breaks any of our tests, which is like really, really nice for stability. And just like not having to worry about as much like putting as much work into upgrading V8 in Node, because like they're also like trying to take care of that on their own. Some more longer term things. Okay, so Chakra Core it's a fork of Node that's still like pretty actively being worked upon. I'm not sure like when they're trying to like get that into the main Node.js repository, but they do have releases that you can check out. Like you can't install them. I mean, I think there are things like NVM with which you can install them, but like I don't think you can do it with NVM itself. In any case, you can just like download and run them and see what that does for you, whether it works. I mean, like if you want, try it out, and if you have any feedback, they'd be happy about that, I guess. Also, like, and this is I just like added that last night because like we had our TSC meeting yesterday after the party, and okay, so we're gonna have to look at the OpenSSL story because so currently we're using OpenSSL 1.02. And that is going to stop being supported after 2019. And so like it's already limiting like how far we can support Node 8 because we're using that there. Like usually we would support Node 8 for 4 more months, I think. So like we have to end that early because like OpenSSL is going out of LTS. And so like the most probable outcome is that we're going to support like 3 versions of OpenSSL in Node, which is like still going to take a lot of work in Node 10. And so like that's why I said like it's very, very likely that Node 10 is coming out in April. But like there's also the option of just waiting for OpenSSL 1.1.1 to come out, which is probably going to be in May. And just like waiting for that with the release. We don't really want to do that because like we already delayed like the last like Node 8, the Node 8 release for a dependency. We don't want to get in the habit of that. And we're probably going to make this work some way. But yeah. And OpenSSL 1.1.1 is actually coming with TLS 1.3 support, which is, I don't know if you care about that, but like people who do a lot with security stuff apparently care, so I guess that's a really good thing. Yeah. Okay, one more thing. It's like also one of the things that we just decided this week is that we are actually going to do a runtime deprecation for like the buffer constructor for new buffer or without the new in some way. In Node 10, we voted on that, and just like it's a decision that we're going to have to live with. The buffer constructor has been deprecated since Node 6. So like it's been quite a while, but people are still very actively using it. And there are some, like I don't know if you've ever read up on that, there are some usability concerns that like reach into security issues. So like the thing is, if you like use pass a string to the buffer, yeah, I actually have an example. So like if you have input that's coming from a user and you're going to like parse it in some way and you forget validating the type and then you're going to respond something with new buffer where the parameter is something that you didn't really validate. So like that thing that you think is some string, like which it might not be because the user passed it in. Like if that's a number, like in older versions of Node, you would actually get a chunk of uninitialized memory. It's like you would actually potentially tell an attacker what is in your memory, which is like something you really don't want to do. And still, like we switched to zero filling a while ago. So like they would get a zero fill buffer, but still like they could, like if there's an attacker and they can control your program like that, and they pass in a really big number, like your program is trying to use a lot of memory, and that's actually, it's like if they do that a couple times, your code is just like going to run out of memory. Your server is going to crash. We don't want to have that happen, so we deprecated the buffer constructor and replaced it with buffer.alloc and buffer.from. And you should use those, and like there's going to be a warning emitted in Node 10, like I said, in some way. And be careful. And like try to upgrade your code if you have new buffer anywhere in there, because like you don't want your users or yourself to just like see a warning every time you run that code. Another thing that is like, okay, sorry, kind of thought somebody was saying something. Okay, yeah, streams. So that's also one of the more long-term things, but it's like what I basically spent my last 4 or 5 months working on the node. So like streams have a lot of overhead. So like there's buffering on both sides for readable streams, for writable streams. There's support for a lot of stuff in there that most people like. Well, they do use it, but they don't use it all the time. Like automatically decoding incoming data from like buffers to UTF-8 or something. It's like it's a very complex machinery. You have a lot of different modes to use streams in. Just like it's very complex, and it does unfortunately have a lot of overhead. It's not terrible, but like it's not the way it should be. So like a couple people are working on like fleshing out a new low-level streams API that is not going to have those issues. It's probably going to be pull stream based. And so like what I did, so like that is still very speculative. What I actually did and landed in Node is like a lot of refactoring on the C++ side of things. And so like the goal of that is being able to like have stream A.pipe stream B, just like have that be a fast path, just like not calling into JavaScript streams at all, just like passing the data right through in C++, which is like, if I can make that work, it's going to be really, really fast. It's cool. And so just like, so you know where we're at, Node 4 is just like about to expire. like if you use Node 4 anywhere, just like get rid of that because like it's only supported for another month. Node 6 is being supported until like 1 more year, which is also like you might want to think about starting to move away from that. Like I said, Node 8 is supported until December 2019 because like OpenSSL expires then, 102. Node 9 is like also like, I mean like when I'm talking to people, like some of them are not that aware that like our odd number releases like Node 7, Node 5, Node 9, like they're just like they basically stop being supported when the next major release comes out, like Node 10. We're still going to do security releases for like another 2 months or so. But basically, like if you use an odd numbered release of Node, that's cool because like you should, because like it's basically a peek into the future. But yeah, just like if you're using that, just like be prepared to jump to Node 10 like very, very soon. And that's it. Thank you for listening. If you have any questions, just like you can come to me. If you have anything that Node could do better, or that we could do better, or that you want to change in Node yourself, just like come talk to me.
That was awesome. I have a question. You mentioned some of the API have some rough edges. Will there be plans of a soft release?
I mean, the truth is, I don't know.
I'm glad that some
because,
people
like,
got it.
Because, like, I mean, async hooks has been, like, the feature I mentioned had been out for, like, 1.5 years or something like that now. And something that a lot of people put a lot of work in, but, like, it's like it might just be that we're going to have to live with having a really low-level API for this. Just like, I don't know.
That's fine. And also, I wanted to talk about one of the points that you mentioned in your slides, which is some people do feel a little bit disconnected to the Node community. Like I remember the first time I attended a Node conference, I was a little bit lost with the you know, some of the language that it's used. Like at first I'm like, what is a working group? What is TSC? What is TC39? What is all these things? What's Chakra Core? What's, you know, just so much things that I don't understand when, you know, first go to a Node conference. Like, what do you think, I mean, my question is, what do you think someone should, you know, do to kind of feel more connected to the community?
I mean, that's a good question. It's like, practically speaking, like if you like want to do that right now, and you want to know what you can do, that is probably going to be follow a lot of Node Core people on Twitter or something like that.
To follow Anna on Twitter, that's what.
I mean, like that doesn't really sound like good advice, and because like you know that's not the way things should go. I'm not sure I can give a better answer, like without like thinking about what we could change to make that easier, you know.
Yeah, I think Node's done really good with like the contribution page, or like you know the working groups and being able to join those things. So I mean, I just honestly Google it if I don't understand, and I think I find some answers to that as well.
Yeah, I mean, like the whole topic of like getting involved in Node Core, it's kind of tricky because like it's really not that hard to get like a couple of contributions in, but like if you actually want to do some more long-term work on Node itself, which like is always help, that is very, very welcome. Like we don't always have great ways to make that happen for people who aren't like around constantly, who aren't able to like spend like a significant portions on their time on it. And we've had that problem for a while and just like haven't really gotten to a really good solution for that. Because like the fact is just Node is a pretty large project, and like I get like 400 mails every day just from watching the main repository, which is like, It's
Yeah,
tricky.
that's fair. Awesome. Are we ready for our next talk? Yeah. Thank you so much, Hannah. So Dan is a developer who loves empowering other developers by building tools. He works at Facebook, working on React. He has a few open source projects out there that you might use, like myself, React, like working on React at Redux, and all these things that help us try to be better and more productive developers.
Also, right before the event, he tweeted this almost a little clickbaity tweet, and I'm going to read it if you don't mind. Using a strange new API, I have never felt this productive using React before. You're going to hate it. Then you're going to love it. We'll spill some beans in a week at JSConf IS. Well, now here we are. Let's hear it from Dan.
All right. Hi, my name is Dan, and I work at Facebook on the React team. And in this talk, I want to talk about the future of React. And originally, when I planned this talk, I thought that I would talk about React 16 release and then the upcoming React 16.3 release, which finally fixes the context API, and then talk a little bit at the end about the future of React. But I was playing with some features that my teammates have been building, like future features. Some of them we've talked before, some of them we've never even talked before. And I realized that I actually want to dedicate my whole talk to these new features that aren't available yet, but I find them pretty fascinating, and I hope you like them too. So, disclaimer, I'm going to show the demos. This is a very kind of demo-oriented talk. The things that I'm showing are not production ready yet. The exact APIs will change. Don't fixate on them too much. But I want to emphasize that this is using real builds of React. So these are not fake demos. These are using actual React code. And I want to start with a question. And the question is, as library developers, we need to think about our immediate users, the developers who are building apps, and also the users of our users, that is, the actual people who are using those apps. And so at Facebook, our scale is pretty global, so we need to consider all kinds of connections and all kinds of devices, such as either high-powered CPUs like on a laptop or low-powered CPUs, such as on a mobile device, and either fast or slow connections. And we need to think about how can we, as library developers, empower the application developers to give the best user experience regardless of the device or the network. And is there anything that React can do better to enable them? So when we think about those issues, we tend to group them into two different areas. The issues related to the computing power and the differences in the computing power, and the issues relating to the differences in network speed. And I'm going to refer to this as CPU and I/O. And in the context of React, when we think of the CPU work, we usually think about creating the DOM nodes, creating components, rendering them, updating them, calculating the updates, and so on. So things that tend to be synchronous. And when we think about the I/O work in the context of React, we usually think about the data fetching and the code splitting. So is there something that React could do better in those areas? I'm going to start with the CPU area. And I have a demo. As I said, this is a demo-oriented talk. So this is my demo. Maybe it doesn't look like a real app that you built, but at least it's pretty beautiful, and it's graphic, so it's easy to see from the audience. But what I have here is I have a text box. I can type into that text box. Hello, JSConf. And I have a bunch of charts, and every time I type, the charts update. And I made it so that the longer I type, the more complicated the charts become. So this lets me show that no matter how fast the implementation of component is, eventually if the component tree is deep enough and there are enough DOM nodes, there is enough computation, it's going to slow down. And I don't mean to nitpick on a specific like chart example. You can imagine that instead of a chart, there could be any kind of React component tree. So the main point is just that it's a heavy tree with a lot of DOM nodes, a lot of components, and it updates every time I type. And so already with this level of complexity, when I type, I experience stutter. And I'm the one who experiences it. Maybe you don't see it. So I built a small clock. So the clock shows how the screen updates. So when the clock is green, it means that the last frames were drawn pretty near to each other, so it feels responsive. But if you see when I type, I can see yellow and even red. This means that it takes a lot of time between different frames, so the user experience suffers. And eventually, no matter what kind of app you're building, eventually you're bumping into this problem where no particular component is slow, but you just have so many features and such deep nesting that you have this problem. So the typical solution to this is to debounce the input. So instead of updating the output immediately as I type, I can just wait until the typing finishes and then do a single update. So I can type the input is completely responsive, but then the user experience suffers in the sense that if my computer is actually powerful enough, so like I will remove some characters to make the complexity smaller, I still have to wait until to finish typing to see the results. So this program doesn't really adapt to the performance of my computer and to the complexity of the tree. And this is even more pronounced if I enable the CPU throttling. So CPU throttling is a way to emulate performance of a mobile device, of a less powered device. So I will slow down the CPU by 4 times. And now you can see that even, so I type JSConf Iceland. And even though it waited a little bit, it still froze later because the underlying problem is just that the update is big and it's synchronous. So as soon as React starts rendering, it cannot stop. Well, what if there was a way to make updates asynchronous so that React could start rendering something, but then yield back to the browser? And if there is a higher priority event, like an input, the browser could handle that first and not start the thread. So I will disable the throttling for now. Let's see how it normally behaves in asynchronous mode. So what you can see here is that when the input is short and it doesn't, there is not a lot of computation, it updates almost synchronously. So it feels like as if it was synchronous. But if I type more, what happens is that instead of hanging the thread stays responsive. You can see that it's mostly green. But instead, React just updates the charts less often, and they lag behind my input a little bit. But in many cases, this actually doesn't matter, and it's a completely fine compromise from the UI perspective. Let's see what happens on a slow device. So I enable the CPU throttling, 4 times slower. You can see that it does stutter a little bit, but it's mostly green. And it tries to catch up to my typing even though the device is slower, compared to the synchronous version where it just stutters on every keystroke. Of course, in Relapse, you often can optimize updates specifically, so maybe only part of your updates. And so you can just update those components and avoid a large update. But not every, there are also scenarios where you just need to mount a new heavy tree. So I will unmount this chart completely and then mount it again with throttling enabled. So that's simulating a slow device. And you can see that it hangs every time. And while it's rendering the chart, nothing is interactive. So I can actually click on this clock to simulate an interaction, but while it's mounting, it doesn't register my clicks. Now, debouncing doesn't help us here because debouncing is only helpful for updates. But here, I'm just mounting a huge component tree. So let's compare this with asynchronous mode. And I still have the throttling enabled, so that's emulating a slow device. So in asynchronous mode, you can see that even though it stutters a little bit, it doesn't go into red. And interestingly, the circle stays interactive. So I can actually, I can start mounting, I can click on this, interact with this. So the whole app is still working while the rendering is mounting. In fact, I can even start typing in the input, and it's going to update to my typing. So that was the CPU demo. And I want to emphasize that this is not about the charts or the inputs. We've built a generic way to ensure the high priority updates don't get blocked by low priority update. And in this particular example, high priority update was updating the input, and a low priority update was re-rendering the chart, but it could have been any kind of React component, for example, a feed story that gets loaded, and we don't want to freeze the scroll while we're loading new items in the feed. And we call this feature time slicing. So it doesn't block the thread while it's rendering, and if my device is fast enough, it feels almost like it's synchronous, but if it is slow, then it feels, at least it feels responsive. So it adapts to the device, thanks to browser exposing a request idle callback API that we use for that. Also notice that only the final state was displayed. The render screen is always consistent. We don't get artifacts of slowly rendering something that is going to cause a janky user experience. We only flush when the low priority update is ready. And you might think, oh, maybe I changed those charts to like it's probably a lot of work to make this chart component work like this. But actually, I just used a ready-made component from NPM. I didn't make any changes to it. So we can look at the code, and it's just a regular render method. I have a charts component. It renders components from NPM. I pass data to it, and I call setState. And I use a special flag to tell React that it's a low-priority setState. And personally, I found it very helpful to use version control as a metaphor for this. So when I didn't know about version control, and I would just modify the files as I worked on them, hopefully I never did anything silly that I can't undo. So I would just work on a feature in my application. But then if suddenly in the middle of working on that feature, I need to fix a bug, now I can't do it because I only have one version of my tree, so I have to finish working on the feature first. And this is kind of how React works without time slicing. The React that you know is that it can't interrupt the long update. But when I learned version control, I learned to work on a branch. So I could start working on a feature, work on it in the branch, but then if I need to do an urgent bug fix, I just do it on master. And then I can rebase the branch on top of that. And so this is pretty much how React works with time slicing, except that you don't have to rebase anything. React does that work. So React determines how to apply a low priority update on the top. And it can continue working and then flush when everything's ready, just like I can merge the branch when it's ready. So we looked at what React could do better at the CPU side. What about the I/O, data fetching, and code splitting? I have another demo. That's the fun part. All right. I built a movie app. So you can see this is the app. It has a list of movies. I can click on a movie, It shows a detail page with movie details and the reviews. And that's basically pretty much everything that it does. So it has an app component at the top that renders either a movie list page, which is this page, or the movie details page, which is this page. So there's just two kind of pages here. And the data is currently absolutely hard-coded. So there's like a JSON with the array of those things, and we take the data by ID from the JSON. So what if I wanted to change that to fetch data from a remote API? Let's go to the movie page component. I'm going to remove the hard-coded movie details JSON import, and instead I will import fetch movie details from API. All right. And I'm going to use another function that I'll import from the future. Again, the exact API doesn't matter. It may change, most likely. So I will call it createFetcher for now. Then I'll go to the movie details component. So currently, movie details reads from JSON object. But I'm going to do something different. I will create something called a fetcher. So I'll call it movie details fetcher equals createFetcher. And I will pass my promise returning function, fetch movie details, to it. Now the next step is going to be a little bit controversial. So if you know React, you probably know that you're not supposed to do data fetching in render. So in this talk, I'm going to bend this rule a little bit. And I just want you to follow along with it and see where it leads us. So when React came out, it was pretty controversial. And I think we can make more controversial things. All right, so I have this fetcher object, and it works as a cache. It has a single method called read. So I'm going to call movie details fetcher.read and pass the ID. So what's going to happen is that when React renders the movie details component, it will try to get this data from the cache. But the data is not there because it's not fetched yet. So React is going to fetch the data. And React is going to prevent the entire update from occurring until the data is ready. There is just one more thing I need to do. I need to tell React that it's actually OK for the transition from this page to the details page to be asynchronous. So again, the exact API is probably going to be different. But here in the movie click, where I set state show detail true, I will call something called defer set state with the same state. So let's see if that works. I click on an item, it waits, and it loads. And if you don't believe me, I actually built a small debugger here. So it shows the pending requests and how requests happen. So if I remove everything from the cache and I click on the movie, there is a request here. And when it comes back, React renders the detail view. Now you might think, oh, there must be erase conditions. And maybe you think that this screen is not interactive while it's fetching. No, it's interactive. I can click here, I can click here. It's going to load the right one. Now it's in cache. I can go back. I can click on this movie. It's in cache, so it renders instantly. However, what if the latency is high? What if the network request takes a lot of time, like in this example, 3 seconds, but it could have been like 15 seconds. So now if I click on a movie, it seems like nothing is happening if you don't have the debugger open. So that's not a very good user experience. But we can improve it. So I'm going to import something else from the future. It's very convenient to have access to the feature. I'm going to import a component called a placeholder. And I'm going to say that if anything inside the movie page is not ready, we're going to render a placeholder. If the movie page takes more than 1.5 seconds to load, so that's a delay milliseconds argument, then I want to show a spinner. So what React is going to do is it's going to try to render this component, but if any of its child is going to render as much of the tree as it can. But if any of the children are waiting for async dependencies, it's going to wait for those children. And if it takes more than this amount of time, it's going to display the placeholder until those dependencies are resolved. So let's see how this works. I click on a movie. In this case, my default latency is 1 second. So it actually feels almost instantaneous. So I don't see the loading indicator. But if the latency is high, 3 seconds, and I click on a movie, then it shows the placeholder, and then it shows the real thing when it's ready. Here's another interesting thing. Even while it's showing the placeholder, the app is fully interactive. It is never frozen. So I can pause all new requests, start fetching, imitate the fetch. It takes a long time. But say I want to go back. I can actually go back. So the screen is always interactive. Now we just fetched the details, but what if we want to fetch the reviews as well? To do that, I'm going back to movie page component, and I'm opening let me remove the hard-coded JSON import, and instead import fetch movie reviews. And I'm scrolling down to my movie reviews component that currently reads it from JSON. And I create movie reviews fetcher. Create fetcher with fetch movie reviews. And again, I just call read. I said, movie reviews fetcher dot read for props ID. So movie reviews and movie details are siblings, but React is going to wait for both of them before continuing. So let's see if the latency is 1 second, it's waiting for both, but both resolve in time, so it doesn't display any intermediate loading states and the page doesn't jump with spinners. But let's say that I pause new requests, I start fetching, I'll let the reviews come through first. Well, React can't render reviews alone. It's important that the screen is always consistent with what's in the render methods. So React is still showing the placeholder. But when the details of the movie are loaded, this is when it shows everything together. Now this may be fine, but there is a downside. What if I actually don't care about the reviews that much? And I don't want to delay showing the details if the details loaded first. Well, to do that, I use the placeholder component from the feature. So I can wrap the movie reviews component in a placeholder. And I can say that if the movie review specifically took longer than a second to load since the interaction, we actually don't care about them that much, and we're going to show another spinner with a medium size. Let's see what happens. So I pause all new requests, I start loading the movie, and I load the details first. It shows the details, but the reviews are still loading. And when the reviews are ready, it shows the reviews. And again, there are no race conditions. I can go back, I can clear this, I can start fetching this, start fetching the reviews, go back, go here, start fetching the details. It knows exactly what's the right thing to do, and it respects the props that I pass to it. But we can still make the user experience better. For example, when I just click, if the delay is less than a second, it's nice that the screen pops in when it's ready, but before that happens, I don't have any visual indication that something is happening. So can we fix that? Yes. I will go into the app component, and I will import something else from the feature. It's called load-in. So this is not the final API. This API is most likely to change. But for now, load-in is just a component that gives me a render prop called isLoadIn that lets me decide what to show. For now, I'll copy paste what I already have here, so either the detail view or the list view. But I already prepared my movie list page in a way that I can pass a load-in ID to it, and it will show an inline spinner. So for example, if I pass load-in ID equals 1, it shows a spinner like this. If I pass load-in ID equals 2, it shows a spinner on the second movie. So what I'm going to do is I'm going to make load-in ID an argument to render list. And I'm going to call render list. So if we are currently loading, which is what we wanted to ask React, then I just pass the current ID. Otherwise, I pass null. And I can even remove the main placeholder now. Let's see what happens. So now when I click, it shows an inline spinner. And again, no race conditions. I can click here, then click here. It shows the right thing. The screen is always interactive. And now this is cached. So this is all cool, but we can still improve the user experience even further. For example, currently we show the movie page, we load the code for the movie page right away, but we don't actually need it until we click on the movie. So I'm going to replace this with a component that does code splitting. So I call it movie page loader, and I define it above. It takes the props and passes them to movie page. So if we are code splitting, do we need to show a spinner while the code is loading? Or does the question even make sense if we have these new primitives? Let's see. I'm going to import create fetcher again. And I will create a movie page fetcher. To fetch the movie page, I will use the dynamic import syntax. So I will return a promise that returns import to movie page. And I'll remove the static webpack import, so it's not going to be in the initial bundle. Finally, to get the movie page component, I call the read function on the fetcher and read the default property from the module because it's a default export. So let's see if that works. I click here, there is no global loading indicator. If the request takes fast enough, yeah, I just added code split into my app. But if the request is slow, oh, I guess I removed the fallback, so yeah, that's not gonna work. But we can check that this actually did something. So if I refresh, I clear the network tab, and I press, you can see that there is a chunk here. So you can see that this component truly was loaded with code splitting. There is still one improvement to the user interface that I can make here. You might have noticed that this movie has a taller poster than other movies. Let's say that we don't know their sizes immediately. So when I click on it for the first time, the page jumps a little bit when the movie loads. So can we avoid showing the page until the image is ready? Well, we can go to the movie page component and find the movie poster component that renders an image. And I will create my custom image component with capital I that just renders the browser image, except with a twist. I create an image fetcher, which is a fetcher. Now I need to return a promise. So I return a function that returns a promise that resolves when I create a browser image object to preload the image. And when that image loads, I resolve my promise. And I start the loading process. And now I say that the source is imagefetcher.read prop source. I'm bad at this, right? Yeah, this should be an argument because I pass it to the read, so it's going to come out here. Now, if I click on it, that didn't work. Okay, it's a live demo. Some things don't always. Oh, right, I forgot to use my image component. That's why you should look at the lint warnings. So let's use the image component. Now click on it, and it jumps on the page when the image is ready. And this was the I/O demo. We built a generic way for components to suspend rendering when they load asynchronous data or dependencies or really anything asynchronous. And we call this feature suspense. You can pause any state update until the data is ready as specified by the components. And you can add async load into any component anywhere deep in the tree without plumbing all the props and state and hoisting it up and using Redux or anything you usually do for that. And on a fast network, the upside is that you can make it appear very fluent and almost instantaneous without the jarring cascade of spinners that appear and disappear all the time. But on a slow network, you can be intentional about designing the loading states and not just let them be artifacts of how the code is written. Instead, you explicitly design which loading states you want the user to see and how granular or coarse they must be. And there is both a high-level and a low-level API. So the API that I showed you is a high-level reference implementation that we're going to provide, but there is a lower-level API that libraries can use to integrate with this. And again, I found it helpful to use version control as a metaphor. So when I use version control and I start working on something, I do this on a branch. But sometimes maybe I can't continue working on the feature because I'm waiting for the designer to give me the final design. So I put that work aside and I can do something else. And this is how React suspense works, is that React knows that some of the children need some async dependencies, so it just suspends that tree. But it can still handle higher priority events, so this is why I was able to click on everything and continue navigating through the app. And later, just like I can rebase my old branch when I finally have the designs on top of the master, React rebases the suspended update and can continue when the async dependencies are satisfied and then committed to the DOM. So coming back to my question, how can React enable better user experiences for people with different devices and different networks? We think that time slicing helps the CPU case, and the suspense feature helps the I/O case, is that we can be more intentional about designing for slower devices and how they should behave, but we can also provide better experiences of fast devices. And you can see that there are a lot of similarities between these two axes. So this is why we don't really think these are separate performance problems. We think that both the main problem here is not the performance but scheduling, and the solution has to think about the scheduling. And so we call this suite of features async rendering in React. And our goal is to let app developers adapt to users' constraints, such as device and network, to make fast interactions feel instant without the janky things popping out of the screen, and make slower interactions feel responsive and be designed intentionally. And importantly, this is still the React you know. This is still the declarative component paradigm that if you use React, that's what you like about it. So it's not ready yet, but these are not fake product, like you saw me really using it. So it's a real thing. There is a pull request for this, and there is more work to be done to enable this and to ship this as a stable feature, and we hope to deliver it this year. Thank you.
Dan never fails to blow my mind every time he does his talks. It's so awesome. Thank you so much for that, Dan. And I think it's time to announce the break. We're about to split into two, so choose your tracks wisely. Choose
this-
mine. Choose mine.
There's going to be a 40-minute break, and everyone has to leave this room so we can set up the divider thingy. So may I suggest that in this 40 minutes, you go to the Björteloft and grab some swag, because this time we decided to team up with Zoan because this is a winter season conference, so get warm by grabbing some goodies from upstairs, 5th floor. Go now.
Choose your tracks wisely. I heard Katla is really good.
Hei, hei. 1, 2. Hei, hei. 1, 2. 1, 2. 1, 2.
Spurning. Vet ikke. Divided.
DVD. DVD. Hello, hello.
Var búið að testa hljóðið kannski? Veistu, varstu að setja upp í gær? Já. Þannig þetta er bara ready? Já.
Hei, hei. 1, 2. 1, 2. Hei, hei.
that doesn't look good. Can you try?
Here, let me, the settings. I believe, yeah, let's do settings. Or system preferences. Arrangement, mirror. So then, why is it so skinny?
I'm gonna call. Excuse me. Can I put this mic on it?
Do you know what's happening?
He's gonna fix it. It is something with the resolution. Okay, is this okay?
Yeah.
Can I fix it a little bit? Okay.
Let me try. Yeah.
I have like a Thunderbolt to USB-C and a USB-C to it.
Oh, it worked. Perfect. Oh my god.
Dongle trends to see if
A what?
the dongle trend.
Yeah.
Thunderbolt to USB-C and USB-C to HDMI.
Day 2 should be fine.
How's everyone doing? Woo! So quiet, I feel. How's everyone doing? That's better. That's how loud you should be when someone comes up here on stage. Especially our next speaker. His name is David. He comes from Microsoft. He's very passionate about open source, loves talking about web-based technologies, JavaScript, CSS, and he is going to talk to us about simplifying complex UIs. Who here works on, apps and thinks that they've gone like, bananas and it's way too complex for them to handle? So majority of the people in the room, me included, it's, it can go into unbelievable, complex things. And I don't know what a finite automatic state chart is, but we're going to find out. So here's David to talk to us about, complex UIs.
Thank you. Is this on? Can you all hear me? All right, hold on. There we go. All right, so my talk is simplifying complex UIs with finite automata and state charts, although I would have really liked to see a talk called Simplifying Complex Talk Titles with Less Words, but that's okay. I know what you all might be thinking right now. This new React API, a little bit scary, but I have some helpful advice for you. There's actually a really good book in order to understand how to best work with it, and it's doing whatever Dan Abramov says to do. I read this book, so I'm totally fine with the API, but funny enough, the second half of his talk is sort of exactly what I'm talking about today, except in a more general sense. So I want to talk about it, though, not in the context of React or Vue or Angular or any of the last 3 frameworks that came out last week, but I want to talk about it in a frameworkless context. Because this is an idea that doesn't just apply to any framework or no framework in general, but really any programming language as well, and we could see how it could help us simplify our UIs. So I'm a pianist. I've been playing piano for about 20 years, and so this is the approach that I take to software development, just trying to approach it with how I learn music. And so I made the analogy that if software is music, then developers are composers, because we're taking that music and we're composing it in a way that is applicable to any language or any platform, and we do so in a variety of ways. However, music's interesting because with music you have music notation, which you just saw there. Let's go back and see it. So this stuff right here. Now, this music notation is hundreds and hundreds of years old. However, the exact same notation is used today to represent music from Baroque, classical, romantic, whatever the hell Bjork is. It represents all of that in a declarative, succinct way so that you could give a musician who understands how to read sheet music and they will be able to play it. And this works for all instruments and all musicians of all levels. So I was wondering, what is the music notation of user interfaces? What do all user interfaces have in common, and how could we represent that declaratively? So when we're working with software, we usually deal with APIs. Now, APIs, or at least good APIs, have 3 main qualities. First of all, they're well documented. You could read the documentation and understand exactly what's happening with the API. They're also very predictable. The API is going to work the exact same way every time. And they're also testable. You could test against an API. They either provide mocks for you or have a test database or something like that. So user interfaces, though. User interfaces are really, really complex. I mean, does anyone find developing user interfaces easy? All right, so those of you watching online, no one raised their hand, which is good because I would have called them out if they did. We have to deal with something called a human API. That's all of you, that's all of our clients, everyone we work with. Human API is undocumented, we're unpredictable, and we're untestable, and we're also extremely buggy. If you don't believe me, just turn on an American news network, and you'll see proof of that. So I work for Microsoft. By the way, I'm not relating Microsoft to any of this terrible API stuff, I promise. And at Microsoft, we have more than 50,000 software engineers throughout the world, and at least 7 designers, I'm sure. And we also serve 1.5 billion customers, and I think this is just for Windows, so it might even be more than that. And so when we're developing user interfaces for 1.5 billion people, we have to just imagine all the different ways a user could use the user interface. And this is different cultures, different languages. You wonder why diversity is so important in tech? It's because we have to reach these 1.5 billion people. So we don't develop software for just one person. However, when we're developing software with just the happy path in mind, then that's essentially what we're doing. We're assuming that there's this ideal user who's using our applications in the exact way that we want them to. But this never happens. So we're going to take a look at a code example here. And I don't want you to read too deeply into the code. I just want you to see if you sort of relate to this. In this example, we're going to be creating a sample app where we query the Flickr API, and then we show the results. So very similar to what Dan was doing with movies in his last talk. Okay, so it's pretty simple, right? We do a fetch, then when we get the data, we show it. Are there any bugs here? Are we done? Well, let's say the data takes a long time to load. Okay, so now we have to set this loading flag, loading is true, and then once we finish loading the data, then we have to set loading to false. Are we done? No. What if we have an error? Well, we have to hide the loading screen, show the error, right? But are we home free yet? No, because we also have to make sure that we clear the error once we try to search again. And so, as you can see, the complexity is getting bigger and bigger. So now my onSearch event handler is getting extremely huge, and I'm sure that many of you could relate to this code, and many of you say, yeah, some of my code looks like that. Sure. And so what if your boss or your PM comes to you and says, we actually want the user to be able to cancel the search because sometimes it takes too long. Sometimes they want to search for something else. So that logic gets even crazier. I don't know if you could read that. I'll zoom in for you. But there's a lot of complexity in just one event handler. And so, of course, you might know this as spaghetti code, where our code quickly gets unmanageable. And some of you might be senior engineers, and you might be thinking, I don't do spaghetti code. All of my code is modular and layered and separation of concerns and all that. And it's true, you might not write spaghetti code, you might write lasagna code, which is this is spaghetti code in layers. So this is called the bottom-up approach. And the bottom-up approach is whenever you have an event, like on-click or on-change or something, you do all of the logic in that event. And that logic could refer to just so many different actions, and some of those actions might change the state. But you have to choose which actions are executed carefully. Otherwise, you might edit the state in the wrong way, and you have to just add if, else statements and switch statements everywhere, and it gets really bloated really quick. In fact, there's a lot of downsides to this. First of all, this bottom-up code is very difficult to test because all of the application logic lives in your mind. So when you're writing your tests, you have to just output it from the developer's mind onto the tests, and it makes it really hard to work with other developers. Also, the code is difficult to understand. The code that I just showed you for showing and hiding the gallery, if you were to try to parse that as a brand new developer working on the project, you would find it really difficult to do so. The code will contain bugs for sure because there's going to be edge cases that you might not have considered. It will also be difficult to enhance, just like we've seen with cancellation. And features, such as cancellation, make the code worse. They explode the potential possible states and actions that could happen in your application. So here's some intuition for moving forward. First of all, we have the realization that UI components are not independent. We have all these frameworks that they isolate components and they say these components fit in their nice little box and we could just stick them in the page anywhere and they're just going to work. However, to the user, there's no such thing as isolation. Everything they see on the screen is in the exact same context, and we have to coordinate from components to component. So another realization is that actions, which is what happens when you do an event, are based both on the event executed and the current state, so the context. And it's also that this event action paradigm is too simple to represent all the possible states our app can be in. So, what's the solution? Finite state machines and state charts. Now, I know that a lot of you might have heard of these before or might have studied it in school. And the problem, though, is that even though you might know what these are, you probably haven't applied it to user interfaces and applied it to actual software. So looking up material for this too could be a little complicated. So I'm a visual person. I'm going to do this in a very visual way so that we could break it down. So finite state machines consist of 5 parts. First, you have an initial state, such as it being idle. And then you have your finite number of states, which represents the states that the app could be in. And when an app is in one state, it can't be in the other state at the same time. You have a finite number of events, such as fetching, resolving, or rejecting a promise. You have a mapping from state to state based on these events. So for example, when you're fetching a promise and it resolves, you go to the fulfilled state, and same with reject and the rejected state. And then you have a finite number of final states, which we're not going to talk about too much just because user interfaces can be, continuous. We could just keep using them, and it's not like it says, all right, you're done using it. Go uninstall Instagram or whatever, because you're not going to need it anymore. And by the way, if you go to promisejs.org/implementing, it's going to say promises are just a state machine. So that should give you a big clue of what we're working with here. So the original app that I showed you, the gallery app, can be modeled as this state machine right here. So we start in the idle state, and then we go to search. Then we're in the searching state. If we try to search again, it just loops back because it's like, hold on, we're already searching. And then 2 things can happen. We could either resolve or reject the search results. And from those 2 states, we could search again. And so this is clearly seen by the arrows going from success or failure back to searching again. And so the state machine that I envision looks sort of like this. It's a JSON object, and I like JSON better than just black box functions, just because you could enumerate all the possible states, all the possible actions, and be able to transition from one to the other with a nice, simple function right here. So for example, if we're in the searching state and I get a resolve, then I just look it up in this JSON object. Just searching on resolve, success. And so, JavaScript, they call this I don't know, in TypeScript it's sort of a record, and I guess it's the same in C#, where actually it's a dictionary. In PHP, they call for help. I don't know. All right, so here's an example of what I just showed you. So if I were to search for Iceland, or actually, let's search for goats first. But let's say I don't want to search for goats. I'll just cancel that. So let's search for Iceland instead. There we go. So now you see we're in this gallery state, and when we do the event of selecting a photo, we have a state transition that transitions from gallery to photo. And then we could exit that. We could search again, cancel, search. Let's cancel that. Iceland. And so you see it goes from state to state, and no matter how many times I try to break this app, it's not going to deviate from this state machine that I have here. And you see there's a few extra things, such as actions over here, where when I'm done searching, update the items. We're going to discuss that a little bit in further detail. And also, this is part of an article that I wrote, which gives an introduction to finite state machines. So I use Visual Studio Live Share, or I don't use it, I work on it. I also have to use it. It's called dog fooding. Anyway, and this is sort of what it looks like. And so I don't know if we have Sarah and Burke in here. So here's Burke right now. And basically this, you could think of it as Google Docs for collaborative coding. It's right now in private preview at Microsoft, and I have no control over what they're typing, by the way, and they're typing this in real time. And so with this live share, we could collaboratively code in the exact same document at the same time. And so these are a complex series of events that are happening at the same time. And so we have to manage all of these possible events and all of the possible states that this could be in. I have no idea. Oh, God. Good luck breaking the demo. Well, it probably will, but. Anyway, so I'm gonna move on from this demo before it gets too crazy. One of the big things I had to work on in LiveShare is this whole sign-in flow, because you would think that signing in is easy and signing in, signing out, all of that. But it's actually not. Once you start drawing it out, it becomes a lot more complex. So for example, there could be a sign-in failure, especially from Iceland. I'm so glad that worked in Iceland, by the way, because all of our servers are based in the United States. And so when you have a sign-in success, then you go to the signed-in state. And from there, you could go do two things. You could either share a session or you could join a session. And so what I did was a couple months back, I refactored this part of the app so that it uses an explicit state machine, just like this, because we were getting a lot of bugs. We were saying, what if we're in the middle of sharing and the user signs out? Or what if we join a session and then we decide to share a session at the same time? That shouldn't be allowed. And so we had all of these if, else if statements and switch statements everywhere, and I decided there has to be a better way. So I just did, the simple JSON object approach, and we got a bunch of benefits from that. First of all, this state machine that I set up, it was very easy to add telemetry to it. So I added telemetry, and then I get this very nice visual showing exactly the frequency of how users go from state to state. And so you could see, obviously, most of the users go through this initializing and then signing in state. And then you could either externally sign in or you could sign out. And then you could see that users tend to go to either joining or sharing, at about the same frequency. And so it clearly shows, too, how many users go to the error state and how many users go to the success state for each of these states as well. Now, these are very powerful insights because while telemetry will only tell you an atomic bit of data, here's telemetry that tells you the entire user flow of what's happening. And so we could limit this to user and be able to see a nice path of what the user actually did in the app. So it's sort of like, like those funnel diagrams, except even crazier. We could also use state machines for integration testing. And so this gets a little bit into graph theory, so bear with me a little bit. Over here, we would be using a shortest path algorithm. You could choose, your favorite one. Dijkstra. Is he Icelandic? Like, that sounds like an Icelandic name. Bellman Ford, A star searching. Any of these formulas for finding the shortest path. And so for those who don't know, the shortest path is just going from one state to the other with the minimal cost. And so you can imagine each of these arrows have a weight. And so you just want to minimize, how long it takes to get from one path to the other. Sort of like in Google Maps, finding the shortest DTA from one point to the other. So analytics would provide these weights. And this represents all the happy paths a user could take, which means that, if we want a user to, let's say, share a session and get to the shared state, we would imagine the user going from signed in to sharing to shared, just that simple. And so these could be automatically generated from the JSON structure or a finite state machine graph just like this. But remember, we're not just dealing with the happy path. So we would do a depth-first search algorithm to find all the other paths a user could take. So I know, some of you might be thinking like, oh, these algorithm things, I didn't think I would need them. You sort of do, they're really helpful. And so these represent all the possible user flows. So you could imagine that a user getting from state A to state C might not take the easiest route. They might not go A, B, C. They might take a longer route to get all the way to C. And it also reveals all the edge cases, because when you model every single possible state with every single possible action and you get all of these flows, you're going to basically have 100,000% test coverage for anything that could possibly happen in your app. And of course, these could all be automatically generated. I'd caution against this though, because you would be generating integration tests that, I mean, it would generate a lot of integration tests, which isn't necessarily a bad thing, but when you're doing continuous integration, you don't want your tests to take like 4 hours long. So it also makes software bugs visually clear. By drawing them out, having them on a diagram, you could easily see when I do this event, I'm going to the wrong state, or maybe I have an unhandled event, which does nothing, or maybe I have a missing transition. And so that's shown here too. For example, Dan was showing the example where when you click a movie, it just waits, and then you get the next movie, and there's no loading state. Well, you could clearly see that in the state transition diagram. And also, my favorite, race conditions. These are just made completely nil and void with state machines because you explicitly say, when I get this event, I go to this state. And if I get another event after that that I don't care about, it's not going to cause a race condition because I will just ignore that event. And that's what state machines can help with. Now, I want to talk about Herald state charts, and honestly, this could go on for hours and hours just because there's so much information here. So I'm just going to give you an overview of what these are and how these extend state machines in order to improve the way we look at user interfaces, because user interfaces can get complex, and finite state machines might not solve everything. So with state charts, they're sort of similar to state machines. In fact, they're an extension of it. Except we could have actions too. Actions are the things that actually do things to your state and to the app. We can also have guards which prevent states from going from one to the other on a transition, if something doesn't match the condition. So for example, if I'm trying to search for something and the user didn't give me a search query, then I'm not going to transition to the next state. And so that could be declaratively modeled as well. There's also the idea of nested states and orthogonality. So this is parallel states. I don't want you to think of this as concurrent states where an app could be in two states at the same time, but I'll show you an example real quick. It's more a way of simplifying the number of states you have so that your state machine doesn't look all crazy. And also history, which is a very common feature that many users would want in order to go back to their saved state. So I created this library called XState, which models finite state machines and state charts in a declarative way, so that all you would have to do is use this JSON structure to model your state machine, and then you would get the next state by just calling transition on the current state and the action. It's functional, it's pure, so it's going to work in any framework or no framework at all. It also has the notion of actions, so it will return you an object telling you these are the next actions that you're going to take once you transition to a state. It also has guards, so you could pass in some external state, and it will validate against that external state and say, okay, well, this condition is met, so you go on to the next state. It also has hierarchy so that you could represent and compose state machines pretty easily. It has orthogonality, so you could represent parallel states, and history, so that you could also represent remembered states. In this example, let's say that you're doing a payment flow, and you're either asking for cash or card. The user could switch between them. Then the user goes to the review page. you want to remember, did the user choose cash or card? So that's when you would just go to method.history, and it would remember that. And this is a purely functional, no side effect type of thing. And so, you could imagine the applications of where you could apply this. One example of where you would use orthogonal states is this typical example of, let's say you have bold, italic, and underline. A user could click one of them, or two of them, or three of them, toggle all of them, toggle none of them, and it's represented by all of these 8 states. And you could imagine if we add more options such as align left, align center, justify, then it's going to explode into even more states. So with orthogonal state charts, we just have this very succinct representation of each of these possible states so that we know that, we could go from bold on to off, italics on to off, and same with underline, and we could represent all of those at the same time. And also, hierarchy helps to reduce the number of arrows that you have in your finite state machine. So for example, both the success and failure states, we could search again and go back to the searching state. We could simplify this by just nesting them in a single state, the search state. And so this is fully supported by XState. And so you could imagine how this would simplify just really complex state machines. So I released XState about 6 months ago at React Rally, and since then there has been a lot of development and a lot of people actually using it to make projects such as React Automata and others. And so pretty soon I'm going to be releasing another version, minor version, don't worry, nothing crazy, of XState, where we have improved the developer ergonomics, full I keep saying sexy XML. It's not sexy. Code is not sexy at all. SC XML support and conversion, a reactive interpreter, visualization tools, and a lot more examples. And so in order to actually show you what I'm talking about, here's an example of a visualization tool. So that same JSON object that you passed into XState, and the same one that I used for my gallery app, this is one of the one example of where you would use this. So let's see. So from here, my initial state is start, and I could just hover over this search action and go to this state, and then I could see the possible different actions, events that I could take from this state. So let's say I have a search success. And so I go into the gallery view. And then I could either choose to search again, or I could select a photo. And so I could visually see what's happening in my state machine just by pasting in that JSON object. And so that's very hard to do with just a function. And that's why I decided to do it in a more declarative way. And so I'm going to be releasing this soon. I want you all to enjoy the rest of the conference before I release it so that you could have time to play with it afterwards. That's my excuse, at least. It's not out yet. Now, it would be, sort of remiss of me to not talk about sort of the downsides of state machines and state charts. But the truth is that you all are already creating finite state machines and state charts in your app already, and you don't even know it. However, the ones that you're creating are implicit, they're full of bugs, they're incomplete, and that's just the nature of how we code. So the advantage of finite state machines and modeling them in a very explicit way is that you reduce a lot of complexity up front just by getting rid of your if-else-if statements and getting rid of your switch statements and just having a direct mapping. However, that quickly explodes into many, many different states. So state charts help manage that with a little bit of higher complexity cost up front, but in the long run, you're going to see it's going to be very easy to add features, remove features, and handle different actions and different possible modes of your application. So, of course, there's a lot of advantages to using state charts, and the ones I'm going to quote here are not actually from me. They're from NASA. See, a few years ago, NASA had to send this little vehicle right here all the way to Mars. And they did so using state charts. And so the advantages that they said was, first of all, there's visualized modeling. So you could both model and examine the model of a state chart using visual tools. You get these precise diagrams that tell you exactly what's going to happen when certain conditions are met, when you're in a certain state, and this event happens. And when you're sending something to Mars, you can't exactly just send it there and hope that it works, right? You have to be absolutely sure that your billion-dollar project is going to handle every single possible state. And so they also use state charts for automatic code generation, which, I mean, I'm not a fan of, but you could see how, you know, it could be beneficial. Also, comprehensive test coverage. By using state charts, they were able to generate just all of these integration tests where they could test each and every one and ensure that every single state was being hit and every single possible action or event was being handled. Also, you know, being on a big project, you have a lot of requirement changes. Like, we want to add this to the rover, we want to remove this functionality, we want to change the way this works. And when you're working on a big project and you have these late-breaking requirement changes, then things can get really stressful. With state charts, since you could clearly see the full flow of your application, you could easily add and remove features without worrying what's going to break, what's going to change, what's going to be affected. So there are some disadvantages as well. And the disadvantage is that my screen just went black. I guess that means there are no disadvantages. Anyway, since the rest of my slides are borked, I just want to show you this real quick. I gave a talk about 1.5 years ago. It was actually at JSConf Iceland, and it was about reactive animations. And funny enough, this is where I saw the primary use case for using state machines and state charts, because there was this really complex UI design that I really wanted to model, and I found it actually pretty difficult without using an explicit state machine or state chart. And so what I'm doing here is there's 3 different states, this one, and there's different actions as well. So the user could pan right, but just a little bit, and so I handle that as a transition from going from state A back to state A if, you know, they didn't move far enough. But of course, if they move far enough, it goes to the next state successfully. And also it handles, like, if I'm going up and I decide to go left and right, it's not going to do anything because we're already going up and down. So it knows when this event happens, don't try to go to a different state because we're already transitioning to one state. And yeah. So I also want to mention 2 very good resources. The first one is on spectrum.io. It's spectrum.io/state charts. And this is a community where we just talk about state charts, their possible applications, and how they're used everywhere. In fact, state charts are nothing new. They were invented by David Harrell in 1987, which is, what, 30 years ago? And so this is not cutting edge stuff. And so if people are asking, like, why aren't we using state charts everywhere now? Well, the thing is, they are. In embedded systems or systems programming, people do use state charts in order to model their applications. We don't quite yet, but I think it's about time that we catch up to it. And so Eric Mogensen, who started this community, he made a wonderful resource called The Unfinished World of State Charts. And so over here, if you want to learn more information, there's a wealth of information here, including a ton of resources somewhere. But so that's at statecharts.github.io. And so I really want to encourage you to just revisit your application, revisit the way you think about things, and actually try to visualize things, because you're going to see that by visualizing your application, all of its possible states, all of the events that could happen, that you're going to have a clearer representation of the possible bugs, the possible features that you might add, the user improvements, and everything else. And so I want to thank you all for having me. Unfortunately, I can't show you my last slide because it's not working, but thank you.
That was so awesome. I have a question for you, since I find this really interesting, and I also want to apply this to what I do with working with UIs. Do I have to completely refactor my app so that I can get the advantages of what you just talked about with finite state machines?
That's a really good question. So I know when you're talking about Redux or something, it's like, oh, I have to just pull everything out and just refactor my entire app. But the truth is, with state charts, you don't. State charts can't model absolutely everything, and neither can finite state machines. So what you could do is you could just write a separate finite state machine that sort of represents your app, use that to create tests, and then once you see that all the tests are passing, then you slowly start moving it in. So you could use finite state machines for things as small as, like, should this button be disabled? And then you could just stick it in there, and then eventually just have your app grow and use state machines everywhere.
That's awesome. Thank you so much.
Mm-hmm. Thank you.
And that's actually a really good transition into the talk that'll be the next talk. And it's going to be from Will. He's coming from Colorado. He's really passionate about open source software as well, with organizing events, meetups. Is Will around? All right. So seems like Will's not here. Or is he? Pardon?
I think he's on his way, but I don't know if we could call him.
Oh, I see.
Contact him maybe, because he is somewhere. He hasn't cancelled.
Yeah. Okay. Let's take a little bit of a break while we wait for our next talk. Thank you.
I know. Yeah.
That's super embarrassing for Will. I'm never gonna let him hear the end of this. Well, he slept in like a jackass, and he texted me before this talk started that he was here, but I guess he couldn't show up. He might have gone to the other room, and maybe they're running over. I know we're all like a little late from this morning, but he didn't answer his phone, and he's not responding to text right now. But he stepped out. This is his stuff, so they're probably going back. But
Oh, there's Eric. Yeah, you are in the right place.
I've got one of those new MacBooks too, so we'll see what happens.
Yeah. Anyway, Will is here, so we're gonna get started really soon. And I'm just going to talk a little bit about, Will and Will's talk while he sets up. So Will's a front-end engineer, co-organizes the React Denver meetup. He loves sharing what he could to the community, organizing events, like what I said, mentoring others. And he says that he lives on a healthy diet of Diet Coke and ice cream, which sounds like, a diet. And also, he's going to be talking about testing, about testing using a tool called Cypress, and it's for our end-to-end testing. So now we just discussed complex UIs. Now it's time to, test those complex UIs that we just created. Sweet. You ready, Will?
Oh. Yeah, thanks. Almost. 1 second. Oh, thank you. Is it actually presenting okay?
I think it looks great from this end.
Nice.
Yeah. Anyway,
No,
give it up for Will Klein.
Oh my gosh, I think it works. Cool. Okay. Whew. So I've got to talk about end-to-end testing and why the game has changed. So I actually have a little story to share as well that's kind of personal, but it means a lot to be here today. So this is, my name is Will, and this is my wife, Diane. 5 years ago, we went to our first JSConf in Florida in the US. This is us on Amelia Island. It was a really great time, and I really appreciated that JSConf welcomed not just us in the community, but our significant others and our families. I think it's really important to value that, and I really appreciate that that tradition is continued here today. I had a question at the time that I was trying to figure out the answer to. How do you test your front end? I think we've got some really good answers about how to test our unit tests, how to test our functions, our classes, and our UI components in isolation. I think it becomes more difficult when we try to integrate all these things and put it all together. A lot can go wrong on whether it's our UI or our web APIs, or our backend, or our database, or even our deployments. When we put all those things together, anything could break down, and we could have all the unit tests in the world, and they won't help us in those cases. So the type of tests that try to exercise this are called end-to-end tests, testing things from one end all the way to the other and back. I had a lot of really great conversations at the conference. Sorry, just need to move my mouse off. I had a lot of great conversations, but one stuck out. I met this person, Nicholas Bull, and he talked to me for hours. And little did I know, but his wife was also at the conference, Katrina, and she was quickly becoming friends with my wife while we were hanging out talking about testing. And he talked about all the tests that his team had written. They had thousands and thousands of unit tests, lots and lots of integration tests, and maybe 1,000 or so end-to-end tests, which is quite a lot. They were testing an enterprise app, which is just an app that does way too many things. And I was so impressed with all the things he had to say about their stack and their tools and all the effort they put in. I applied to work at his company, and a few months later, my wife and I moved out to Colorado, joined his team. He and his wife helped us unload our moving truck twice, and helped us settle in, invited us over for the holidays, and became close friends. It was really awesome to have met them at the conference, and now we hang out so much together today. So when I joined this team, I found they were using a tool I was actually quite familiar with, Selenium. So Selenium is a tool written in Java that lets us test our apps from the point of view of the browser. And it's a little bit old, but it's done a lot of wonderful things, and it's let us do something we might not otherwise be able to do. And the way it works is it's got this Java service that just listens for commands. And you write test code in any language, actually, and more often than not JavaScript. And that language would usually use a library to speak the language of Selenium, the WebDriver API. It would send those commands to the service, and the service would queue all these commands and would try to send them to any given browser, real browsers. And so there was just a number of different abstractions and integration and interfaces where things could go wrong. It could be that your test code had an issue, or you're using the API different, and all the different APIs to work with Selenium in every language, and even within JavaScript, there's several choices. They're all a little bit different. Those could have issues, or you could be using it incorrectly. The Selenium service queuing up those commands and sending them to the browser drivers. For each browser, the browser drivers could have bugs. There are a lot of ways where this could go off the rails just with this architecture. So the greatest complexity of all is our app. I find that as we write modern JavaScript apps, we're doing a lot of things now in the browser. We're making all these different API calls just when the page loads. Those come back in different timings, different orders sometimes. That can cause just different behaviors in our front end. Whenever the user interacts with the with our UI, that makes more calls, more things happen. And all these things happen asynchronously. So we are rendering, it could finish at any time, and we don't really necessarily know when it is, at least from our test code's point of view. Us as users, as humans, it's very intuitive to us, but when we run our test code, it does exactly what we tell it to do. And if it clicks a button and then it starts to re-render, and we try to do the next thing, we need to be very careful about knowing that it finished rendering, or we might get something very unexpected. So the greatest problem of all is when we take this Selenium architecture and combine it with the complexity of our apps. It's really a recipe for just frustration. And what we'd find is we'd write a commit, and we'd run tests locally, and everything would look good. We'd push it to the build, and it would fail. Some tests would fail, and usually an end-to-end test. And we'd run that build again, because it was a test that we shouldn't have broken, and it would pass. And we'd see this over and over again, where different commits would just randomly fail just different tests. And we call this flakiness. And the problem might be something with the Selenium architecture. Often it was a combination of that and just the complexity of our app working in with different performance characteristics. Particularly when we're on build environments, they're virtualized, things can slow down, or the database, anything could make it just work a little bit slower in one part of the stack at any given time, and just something will fail somewhere. We ran into this so much, we had a build job that would just continuously run and check the latest commit on master and just run all the tests. And it would just flush out dozens and dozens of tests that just failed a lot. Even with that, we just kept tripping over this issue over and over again, tests that would just fail once in a while. Why do we keep doing this? Well, these tests we found to be extremely valuable. As I said before, you could have all the unit tests in the world, but if everything integrates and something breaks down, you're going to have a really bad time. And worst of all, your user's going to have a bad time. I mean, this, at the end of the day, everything we do is about building a user experience, building value so somebody can do their job or do that part of their life or make that one thing easier that gives them joy and makes them happier or productive. So we invested as much as we could into making this better. I mentioned the flaky finder, but we even tried to make our tests better in a lot of ways. One example, we wrote some test helpers that would try a command, and if something didn't work right, it would retry it a number of times or for a certain timeout. And this is called an implicit wait, just building it into the API so you don't have to do that manually in your code. So we also found that it helped to mock some service once in a while, mock some services to test certain edge cases or certain scenarios, large data, things like that. Doing that, we wrote some of our own service mocking libraries to make that process easier. We invested as much as we could into making the developer experience of using our tests and running our tests better, so we keep doing it, despite how painful it was. So after a while, I joined a new team and got Selenium up and running there, and that went all right, and ran some of the same issues. And then just this past fall, in October, I was consulting on a project. And we had run into a serious quality problem. We didn't have a dedicated QA team, and as much as we smoke tested our app on every single commit, there were always cases we missed. And at any given time, something would stop working, and you didn't know when it happened. So we decided to write some more tests. I pulled the story to write the end-to-end tests. And I pulled down Selenium, and the first thing I had to do on my year-old MacBook was install Java, install the JDK, because I didn't have that, and you need that for Selenium. I thought, wow, I still wish this was written in JavaScript. So the next tool I tried was Cypress. And Cypress was something that I had actually held off on using for a while. It'd been closed source up until, I think, May last year, and it had been in private beta until October. And they had built a company around some of the premium CI features, but now that it's open source, everything that you need is just right up there on GitHub. If the team stopped doing what they're doing, the community could pick it up and run with it. So I'd really waited to use this until it was open and freely available. It was something I wanted to use that was MIT licensed and ready to go. So I actually used it for just maybe 2 hours, and honestly, I was blown away. I was so shocked by how different and better my developer experience was that I wrote a proposal to a conference after just working for a couple hours, and here I am. So I have a few demos that I'm just going to run through to show you how to install it, set it up, what some of the tests look like. I don't want to get too hung up on any of the syntax or any of the commands. I just want to give you an idea of what it's like. So the first thing you do is you just npm install it. And this actually will do a download from their website and pull down the right Cypress app. There's an Electron app involved, so it's going to pull down based on your operating system and your CPU architecture. Next, you open it. And the first time you open it, it kind of initializes some things. It makes sure it's verified and it's like the right thing and all. And then when it runs, there's this little pop-up saying, hey, to help get you started, we put some files in the file system. And you might want to take a look at that. The files are basically examples. This is just nice. There's an example like fixture, there's example plugin, custom commands, and an example spec. And the example spec is just this kitchen sink of all the different commands you might want, and it just gives you that quick reference right in the repo. I mean, you can go to their docs, but it's just all right there, and it just kind of gives you a little head start with what you might want to try to do. The nice thing is, from there, it starts to get very familiar. If you've ever done BDD-style tests, whether in Jasmine or with Mocha and Chai, the syntax is going to look very, very familiar. Let me make this just a little bit bigger. That big? Oh, yes, that worked. Good. All right, cool. All right, so this is just part of a spec file. And the first thing is, like, there's this top-level describe. We're describing our app or some view in our app. And we can have before eaches, if we're used to that, and do things before every test. And most commonly, we'll load the page, load a route on our app. And then from there, we can have nested describes or contexts in Mocha. And we can have our it shoulds. It should do a thing. It should focus on the to-do input field. And then from there, we can start using the Cypress API. In this case, we're doing two things. We're doing site.focus, which says, hey, Cypress, look up what's currently focused in the window. And then it tries to do an insertion. It does a should, and it says it should have the class new to do. There's something interesting about the should, and this whole, you'll see some chaining here, and there's a reason why they use that style. See, the should has this context of I'm trying to do a should on something that was focused or something that I tried to get in the DOM. The should will keep trying until it's true, until there's a timeout. This is really nice because when we first load our page, like we talked about asynchronous rendering, the first thing that's focused might just be the window or the document. That thing hasn't rendered that has that class. So it's going to keep retrying until it gets that, until it passes. And this permeates all of their APIs, and having that context and doing things just a little bit more intelligently by nature. I'll show you one other example. This is an example that is quite common where you try to just get something based on a selector. It's using jQuery under the hood. So anything that's really a valid selector works, and you can even do things similar to in jQuery with DOM traversals to like get siblings or next or parent, etc. And then we just type in a little thing we want to do. And another thing I'll point out is instead of having to memorize those key codes, like what key code do I need to put in to automate an enter key or an escape key, they just use like enter with curly braces. Just nice and convenient that way. From here, I want to show you what running the test looks like and what debugging the test looks like. All that other stuff is relatively similar to Selenium in terms of like we're just writing tests and using some API. This is where I think it starts to take off. So the first thing is you can run it headlessly. By default, it runs headlessly, like on CI or if you're just running tests locally before on a pre-commit hook. There's some nice results there telling you everything that passed, and there's also recording by default, so you can actually replay the recording of your app and all the tests if you want. Here's where it starts to get a bit different. There's an Electron app. And the first thing that happens when you load the Electron app, there's this yellow warning that says, hey, can you make sure you're running your web server? There's a configuration you can set, your base URL, and if you configure that, it'll actually check that when this Electron app runs to make sure that you're running your web server. I can't tell you how many times I've forgotten to run my local dev server when I'm running my tests. And it just tells you right away. And then from there, you can also choose which browser, and just whichever version of Chrome you want right now, and or Firefox and Edge and all that eventually. I'll get to that. And then you can run your spec. So from here, we get into the test runner. The test runner is pretty neat. This is not this part. Run it? OK, good. So this part's pretty neat. This is running in a browser, like a sandbox browser environment. And the test runner is this whole, like, there's our tests on the left. There's this header on the top that has like this information about what tests have passed, which tests have failed, how long it's been running. We can stop and replay it. There's a URL preview. There's a little target icon. That's actually a DOM selector playground. We can click on that and play around with selectors to find things in our app. And there's also viewport information at the top. And on our right is our app. So this might seem like a little thing, but this, just having it right in the same window is very convenient. And there's a very good reason why they put this all in the same window. So that thing on the left, where all our commands and all our tests are kind of logged, that's called the command log. This thing is cool. When we click on anything in there, expand one of our tests, we see all the commands that our tests tried to execute. If we click on any of those commands, it'll jump to that part of the test. It'll actually go to the DOM. It takes DOM snapshots throughout the test, and it replays those DOM snapshots. So we can actually jump around our tests sequentially or out of order and replay the state of our DOM and see what's going on in our app without having to, without much effort. And you'll see there's this thing at the bottom of our app that says before and after. Certain commands have this context of before and after. I think typing is one of them. So if you go to type in something like a new to-do, you hit before, you can see the to-do before something got typed, see what's going on, debug it maybe. And you can click to the after and see after you've done the type command. This ability to replay the DOM snapshots and walk through our tests just by clicking on the command log is a night and day difference from anything I ever experienced with Selenium. The workflow I was used to was setting up a debugger and trying to drop a breakpoint in my test or my app code and trying to hopefully stop at the right point running into all kinds of things like default timeouts and the app reloading and test reloading and just all kinds of wonkiness that was just always frustrating. And just being able to walk through my tests, I can see exactly what's happening. And just a little aside, interesting thing, if you write really good tests about your app like this, you can actually sort of document how your app works, and a new user or a new person on the team could look at it and get a pretty good understanding of all the things it does and how it behaves and what it looks like, all of that. So let's talk about debugging, like really debugging. So the first thing is when we click on those things in the test runner, any of the things we click, they have some context of there's a DOM element involved or there's a network request. If we click on them, they just get logged to the console. Normally I'd have to set up a breakpoint and throw in my own console logs to get this information. And it's just right there, like just at a click, we can get that and start playing with it. DOM debugging, you can inspect the state of the DOM in any of these snapshots, and you have that and you can rely on that. I will say, it's not necessarily replaying all of your different Redux states, for example, your true app state. It's just going based on the DOM. Though I have found that in reality, even with an app using React and Redux, I was able to actually interact with my UI in some cases, and things would just sort of work. And there are hooks to potentially do things like inject Redux state and snapshot that stuff. I haven't gotten to that yet. I'm not sure anybody has. But there's some crazy things we can do with this replayability. JavaScript debugging. So if that wasn't enough for me, I found it really awesome that I only needed to run this one app, this one browser, this one app, and this one debugger to debug both my tests and my app code. This replay is just showing hitting a breakpoint in my test code here, and there's also hitting a breakpoint in my app code. And being able to jump between those two contexts, normally I was used to having like a debugger, hopefully a Node because my tests were maybe written in JavaScript, and then another one in the dev tools for my app. And I would be bouncing around between the two, and there's just all this cognitive load that comes with which one am I in, what am I doing where, and bouncing back and forth, and window switching, and just all that. And when you just start to take this this very challenging thing that we do every day, and you put it in a single place, and you just make it that much easier, it starts to make it fun again. So there are some other nice things. So I mentioned we had to write our own implicit waits. Cypress does that out of the box. There's a 4-second timeout, which is plenty. You can make it shorter if you like. You can override that. There's direct access to the DOM. So in Selenium, everything was being serialized to that service I mentioned. And so you're always just getting a serialized version of the DOM. Because everything's running in the same JavaScript runtime, you're actually dealing with the DOM that's in your app from your test code. Like, you just have it. It's just nice. And there's some service mocking libraries built in. They just made it easy to define a route and define things you want to match on, like a method or a parameter, and you can have it return fixture data. It's just rolled up. And that's the thing overall. Like it rolls up all this tooling that we normally be cobbling together ourselves. Sign on for the request stuff, the service mocking, and jQuery for DOM querying and traversal. Mocha and Chai for the BDD syntax in our tests. It takes care of that for us, so we don't have to select them ourselves or maintain those dependencies. And it just becomes this one cohesive package that is well documented on their site. The other thing I noticed about their site, both in their blog and in their docs, they have lots of little tidbits like this. So this is a thing on timeouts and performance, and it talks about this performance trade-off when you start to extend the timeout, which is like a common trap when writing these tests. Something didn't work, it wasn't ready yet, so we'll extend the timeout. Well, I mean, there's a big catch to that, especially if you do it universally. And there's things throughout their docs that kind of throw this out at you, like little tidbits that aren't even specific to Cypress. These are just, like, there's a book in here about how to write good end-to-end tests that could apply to Selenium or whatever else tool you want to use. And I just like that. I like that they're a little bit opinionated, and they just share these things right in their docs. So we just have it. It's just nice that they went that far. There are trade-offs. So I've been talking about how awesome it is. I do want to say, some of the things that it lacks, that it can't do yet, or the things you need to consider. It's a new tool. It's a new technology. It's a new thing to bring into your team. There's always a cost for that. I take that very carefully. And it has a style, that chaining syntax. I actually personally don't like chaining that much. But as I said before, there's a reason for it. They like to maintain that context of what you're doing, so that way they can intelligently do the thing that you're doing next, like an assertion. And they're very upfront about their trade-offs. They have a whole doc page dedicated to this, and it mentions both permanent trade-offs and temporary trade-offs. A permanent trade-off is it runs in a single browser tab. I have seen apps that try to open other tabs to do certain things. You're not going to be able to test those things in Cypress. There's also a temporary trade-off of browser support. They didn't try to support every browser right out of the gates. They just chose Chrome-based browsers. So they got Chrome, Chromium, Canary, and Electron browser. They're working on Firefox. They're just fixing issues on that right now, squashing some bugs, and they're going to have that as soon as they can. And I'm sure Edge and so forth will be next. But that's something that is very important, though. Having cross-browser support is key in a lot of cases. And I would suggest still having some Selenium tests just for those situations that Cypress cannot do them. I find that 99% of the value of these tests is easily covered by Cypress, making sure that we exercise our user experience, all the different views, all the different interactions that we care about. Testing each workflow once, that the user wants to do A, B, C, test those things. Testing any given, all the different UI components at least once. That's also really important. More than anything, I would say it's ambitious. They've basically reinvented the wheel. And anytime you do that, you're going to have your own set of bugs, your own set of challenges. And I think they not only tried to reinvent Selenium, but to add this very comprehensive developer experience on top of it. And that is crazy. If I ever met Brian Mann, the original author of this years ago, I would have told him he was crazy and said, "Good luck. Please try and please succeed." But I don't think it's possible. Don't feel bad if you fail. But here he is. He's what started as an experiment. He got it working. And he's built a team around it. There's, I think, 6 full-time devs on it now. And the open source community is growing. There's 30 more contributors on top of that have made contributions. But there's going to be bugs. There's going to be issues. There's going to be the trade-offs I mentioned. But I'm really glad that they've made it anyway. So I would definitely say that when it comes to end-to-end testing and our ability to test our user experiences, the game has changed. And I would encourage everyone to not just think about unit test coverage, but user experience coverage. End-to-end tests is where we solve that problem. And if you're new to this or trying to get started, do one thing. Write a smoke test. Test that one thing your app says it does. Test that main workflow, do the happy path, make sure that's good. That is going to give you 90% of the value. You're going to cover your build and your deployments, and of course that one thing that your app is supposed to do. And from there you can start to cover more things. But that is the one thing that you could do in maybe a day. I think I had the first few views of our app tested in an hour or two. And then I just went from there. There were dozens of views. It's a very heavy, a lot of another enterprise app. But it didn't take long to get that going. And I like to say this, don't let your users test your app, because if you're not automating these things, that's what you're doing. You could have a QA team. You could be smoke testing this yourself in your own browser. But there's no way you're going to catch all the things that these automated tests can catch as quickly as they can catch. I mean, to test those things manually, what's your dev cycle? You're just creating a feedback loop that could be so much shorter. And these things can run very quickly and catch so much more. So Atwood's law. Any application that can be written in JavaScript eventually will, right? I think this is a good thing. Just a couple of weeks ago, I was working in Visual Studio Code, and I thought, wow, I remember when Atom came out, and before that I was using Sublime. Sublime was great. Everybody loves Sublime. Everyone at least used to love Sublime, and maybe we've forgotten about it a little bit because we've had Atom come out. And at the time, it was like, oh, this is written in JavaScript, an editor? This is fast. This works. This is crazy. And in Visual Studio Code, and I'm thinking now, when I use Visual Studio Code or Atom, I'm not just using those editors, I'm using all these extensions and plugins. There's these ecosystems of tools that have built up around these tools because they were written in JavaScript, because they were written in the things that we're familiar with. And I look at Cypress, I still think we're very much in the early days. It's still gaining adoption. People are still catching on. People are starting to write custom commands. People are starting to write plugins. Like, we're in the early stages of seeing that ecosystem expand and grow and become something beyond what the original authors intended. I really want to thank the Cypress team. They did an amazing job. They definitely ran into all these problems I described that I experienced with Selenium, and said they wanted to do better, and they have. They've built something that not only was written in JavaScript, but tried to solve the developer experience, and tried to make that smoother, and tried to make it encouraging for us to write these tests that aren't always easy. And I think they've done a terrific job. I think their docs are great, but if you need more help than what's in their docs, check out their Gitter chat. I promise you they're really nice and friendly. I want to finish my story, my personal story. This is my family and Nicholas's family. We each had a daughter 2 years ago. They were born a month apart. Our wives are both expecting our second this summer. I really wanted to bring my family here, but my wife is 5 months pregnant, and my daughter is 2 years old and wants to climb over everything. I actually asked my wife's doctor if I should, and she yelled at me. She said that would be a very bad idea. I miss them very much, but I will also say that Nicholas and I, still talk for hours, and he's still teaching me things. And I'm so grateful for having met them at JSConf 5 years ago. Thank you for joining me today, for wanting to hear about how to write tests, about how to do this better, about what's changed. I hope I've given you some ideas about that. I hope I've given you some ideas about what's happened in our ecosystem and what continues to happen with our tooling and how that continues to advance. If you want to talk to me after this, I love talking about this stuff. Please come find me, or find me on Twitter at Will's Lab. I really appreciate being here. Thank you.
Thank you so much, Will. I find your story really inspiring. It's just like a story of mentorship turning into friendship, and even more mentorship after that. I mean, we can all learn something from that, meaning that really talk to the people right next to you, and get to know their story and learn from them. We're all here to learn from one another. So a few announcements. We do have a lunch break right now. We also do have diversity panel happening at 12:50. So go grab your lunch, join us in the diversity panel. It's going to be fun. Another thing is that the SO party passes or party tickets are apparently still available, so you can still buy them. And that's it. Hope you have a good lunch.
Thank you. So much. I appreciate it.
you.
Tiring day. Is it you're hosting also tomorrow too, right?
Bug thinks I'm in New York. It's like 8 a.m.
Oh no. No, I just thank you.
Hey, how's lunch been? No one's a fan of lunch? That's like my favorite time of day. I guess no. I mean, the lunch was great. I think it was good. I love fish. I love salmon. Anyway, so let's get into our next round of talks. It's either people from Iceland that are like really shy or quiet or like don't feel like clapping. This is not like Medium where when you clap you like are giving people money-ish. I don't know how Medium works anymore. Anyway, our next speaker is coming from London. She is born and raised in San Francisco and is a Google creative engineer at Google. And she's going to be talking to us about something that's really cool, in my opinion. It's augmented reality. I've never played with it, but it seems like a really cool technology. So please give it up, and help me welcome Riza up on the stage. Thank you.
Hey everybody. I think my mic is working. Should have done this earlier. Oh, wrong one. All right. So, first of all, let's get this on screen. First of all, I just want to say I'm a little bit embarrassed about my outfit, that I'm not as handsome as Florida over here or Vanessa in the other room. The truth is, I brought a really nice stylish shirt to wear today, but my hotel room didn't have an iron. I called them at 7 in the morning and they took way too long to bring it up, so I just thought, like, you know, I was actually panicking this morning, called my boyfriend and was like, I don't have anything else to wear, just the trekking gear for this weekend, and like maybe I'll just go on stage and look like a mountaineer. So he was like, it's okay, it's a developer conference. And I was like, that's right, I'm gonna just be myself and be comfortable and be really cozy, like a mountaineer talking about augmented reality. So let me just introduce myself. My name is Raisa, and I'm a creative engineer at Google. My team one day was looking for ways to use augmented reality in one of our marketing campaigns. So I took the liberty of just doing the research on my own, seeing what's possible. And naturally, I just started digging out into the history, got really excited about the many, many years that it has gone back, and wanted to share with my team to help them appreciate what it is today, and of course, do my actual job of reporting back what's possible today and in the future. So, what is possible in the future? Actually, and before I start, I want to just make a really quick disclaimer that all this research I did was on my own. It's all public knowledge, and with that being said, I'm speaking on behalf of myself and not on behalf of my company or any of the organizations I'm a part of. So let's step back into history, all the way back into 1901. This was a time before airplanes, before traditional color photography that we know, and nearly a decade before the first talking motion picture. Yet before all of these technological advancements, we had a visionary author called L. Frank Baum, who you see up here. And he envisioned a world in a novel that he wrote called The Master Key. He wrote about a world where one could put on a pair of spectacles, and the people that he would look at, it would overlay a character over their head. And this device was called a character marker. So basically, he's looking around and can judge a person on a single look. So these were some really deep sci-fi thoughts back in 1901. I can't even imagine how he could have come up with this idea. And if the name rings a bell, he's the author of The Wizard of Oz, so maybe it's not so surprising after all. Then fast forward to 1968. A lot has happened in this time. America has built the first 747. We've orbited the moon from Apollo 8. And at the same time, we have the world's first head-mounted display. This was developed by a Harvard professor called Ivan Sutherland. And this display that you see here, it was so heavy, it had to be mounted from the ceiling. And there's this funny video on YouTube where you can see him like spinning around, and all he's seeing is this really simple wire cube. So after all this hard work, you saw this visionary cube in space. And this was a really important precursor to AR, because as you'll see, there's been so many advancements with head-mounted displays these days. And now, looking at 2018, we have a rocket orbiting into space with a car that's now somewhere out there floating. But at the same time, we also have all of these advancements in augmented reality. Everyone is talking about when it's going to be the next big thing for the past few years. Technologists and investors alike are speculating on when this is going to really blow up. So what is happening after all of these years? You see that there's a rich history of over a century ago that dates back augmented reality since at least 1901. So if you look at this chart from Google Trends, in case you haven't used it before, the y-axis is the search interest from 0 to 100, and on the x-axis we have time. So I did a search back until the past 2.5 years to see how interested people were in augmented reality. And as you can see, there's some interesting activity going on here. Suddenly, in the summer of 2016, we see a huge peak, and people are curious about this mysterious AR thing that they've just heard of. And this is when Pokemon Go was released. So all of a sudden, we have people using this cool new app and wondering, like, whoa, what is augmented reality? And what else is possible with this thing? This was probably the most popular AR application, although, as we'll see, it's not fully AR capable, and they're working on that application, fully AR Pokemon Go soon. But this really opened consumers' eyes into the possibilities of AR and really showed the potential for its scale. Then later, in more recent years, around the fall of 2017, we have another peak that's starting to rise. And although it's not as high as Pokemon Go, this was from ARCore and ARKit, which were announced roughly around the same time. And these are developer kits that will allow people to build experiences such as Pokemon Go in a much easier and much more streamlined way. So, as a quick definition, ARCore is a platform for building augmented reality apps on Android, and ARKit is Apple's version for building AR apps on iOS. Looking back a few more years, this is as far back as you can go on Google Trends from 2004. You see that there's actually some activity going on. People are actually interested and aware of augmented reality, especially around 2009. So that was almost 10 years ago. And why does it seem like it's such a new thing now? This is when AR Toolkit was released for web. It's an open source toolkit. I guess if you want to compare it to ARCore and ARKit, this allowed developers to build web-based AR applications. So this was actually, the output would be Flash-based. So this is one of the reasons why it didn't really take on, because users have to install a plugin, and then they kind of have to like use their webcam in a weird way that doesn't feel natural, compared to a mobile device where you can take it around with you, and it makes more sense to like kind of point at what you want to project your AR object onto. So this really shows its date. The documentation of AR Toolkit, or this publication about it, describes what AR Toolkit is. It shows AR Toolkit in action, and as you can see, it's marker-based, so they have this code where it will project the object from the code. And then in the documentation, you can also see that it's using Windows XP and telling you how to use a webcam on your computer. Then later in 2009, we have the introduction of augmented reality into the real world. So Esquire published this issue. It was an augmented reality special, and on the front cover, you had this QR code that you could scan, and then something magical happens. Robert Downey Jr. comes out of the screen and starts like acknowledging you. And then there was also, as you saw on the previous screen, there were 12 pages of AR content, and lots of publications were talking about it, and it was really becoming more noticeable to consumers. So fast forwarding to today, we have back in 2012, Google Hangouts filters, which was actually long before Snapchat, which many people don't know. Snapchat's world lenses. We have a huge advancement of head-mounted displays like the Microsoft HoloLens, and then, of course, Pokemon Go is very well known, and the IKEA, one of IKEA's furniture app from the Apple Store. So what's making this possible today is that we have much more powerful devices, much more powerful browsers that will hopefully soon be capable of AR. Developers are more well-equipped with toolkits like ARCore and ARKit, and hopefully future support on the web will help to bring this technology to the masses. So let's go back to basics and talk about what defines augmented reality apps. So ARCore, again, is the software developer kit that allows developers to use these defining AR features in Android applications. And these defining features include motion tracking, which allows the device to understand and track its position relative to the real world. So a scarecrow you can place into the world and move around, and it looks like it's stationary, just like these people next to it. And environmental understanding, so that the device can detect the size and location of previously, it was only horizontal surfaces, but now with the release of ARCore 1.0, you can also place it on textured surfaces, and there was this cool demo of placing things on the snow, like around the tree, which is pretty cool. And then light estimation, which allows a device to estimate the lighting conditions, and this really helps bring objects to life, because even the subtleties like shadows and brightness can really make an object in the real world look real. So previously, we had a platform called Tango, which allowed augmented reality on these really powerful devices. But as these were very specialized, we decided we wanted to bring this to the masses. And that's when we really focused our efforts from late last year on ARCore, which will make augmented reality possible on more Android devices. So that is a huge challenge, but also a really big opportunity. The fact that there are 2 billion plus active devices out there running on Android, and each of these has their own unique hardware requirements, hardware specs that we have to make sure align and provide the same high quality experience that we want all users to have. So currently, with the most recent release, it works on 100 million devices, which includes 13 unique models that you see here, and we're working with partners to make sure that more devices can support this. And going back to ARKit, this is the software developer kit allowing developers to use the same essential features in iOS 11. The way to describe it, it's very similar to the 3 basic AR features that ARCore suggests. Those are basically essential AR features, not ARCore. Like they can be described for any augmented reality app. And their device compatibility is all most recent Apple devices, so with the A9 plus A9 chip or above, running iOS 11 and up, so that includes iPhone 6s and up, and some of the newer iPads. So let's talk about building for web, because all of this ARCore and ARKit allows you to build native apps, but this is a JS conference, so you guys are probably bored thinking about building an app. We want to build for web. So let's see what's possible. ARCore currently has an experiment where they're exploring the possibilities of web support, which would be awesome because it will lower the barrier to entry and people can build apps and release them out to the web. So this is like a pre-standards experimentation, just trying to see explore what's possible. And it's basically a wrapper of Chromium, and it's extending WebVR features so that it's really scalable and allows for fallbacks and across multiple devices. So they have this cool demo called Article, which you can download on GitHub. Just npm install all the dependencies and run it on the Webpack server, and it's super easy. And just to explain, AR Core for Web is not one single entity. It's basically you're building a web app with AR capabilities. You're using JS libraries to build the 3D objects, and then you are running it on this experimental browser that's supposed to emulate what the web standards might look like. And currently, they have experimental browsers that work on both Android and iOS. So they're called Web AR on AR Core and Web AR on AR Kit, respectively. And most of the examples on the Web AR for AR Core demos are built with Three.js. It's a really popular 3D modeling library that's been used since 2010. Some of Google's projects have used it, including the Poly library, this educational experience called Interland, and all of these other cool Google and non-Google experiments that you see here. And it allows you to create 3D shapes, animations, complex scenes, and gives you some tools to make this a lot easier for you, because as you'll find, 3D modeling concepts are really hard. So this is one of the tools that it provides. It's an in-browser kind of shape editor or scene editor, and it allows you to control all these different parameters. And it's a really good way to kind of start learning 3D modeling, and especially if you haven't been paying attention in math class like I did, you have to relearn kind of UV mapping and vectors and matrix multiplication, and it really sometimes is a little bit overwhelming. But with tools like this, it becomes a lot easier. And if you get good, you can make some crazy 3D shapes like this. But if you are having trouble with 3D modeling, you can also download some models on Poly and find all these different kinds of cheeseburgers. Anything, like just basically search for the term and you'll find different items that are tagged with that description. And if you really like these cheeseburgers, you can just put it all together, start throwing them in the air, and then that's your AR app. So just to highlight what's possible with Three.js, this is one of the apps that my team has built called Qibla Finder, and it helps people find the direction of Qibla, which is the direction of prayer during Ramadan. And basically, we use Three.js, but AR Core and AR Kit were not yet available, and this was also a web app, so we kind of had to get creative. And this is basically just using WebRTC to use the camera and navigation APIs. And basically, it's projecting this into space rather than, as we've learned as an essential AR feature, it doesn't allow you to kind of place it onto a detected surface. So it's a kind of like faux AR, but it's I guess you can compare it to Pokemon Go, where you're not really you're not really throwing the Pokeball onto the Pokemon. It's not on the floor. It's kind of just like sometimes it's floating around. So that's kind of one distinction of what's possible with Three.js and how we need to bridge the gap. So to bridge those gaps, there is a library called 3.ar.js, which kind of detects the device compatibility and enables the AR web utilities by interfacing with the WebVR extension that is exposed by the experimental browsers. So that's what's allowing you to throw things onto surfaces and detect it with precision. So putting it all together, you can create some really useful apps like, for example, this living room modeling. There's some really useful things you can do for consumers to make this really widely adapted. And especially if it's available for the web, then people can just reach these experiences from a link and access them if their device is compatible. So again, the Web AR on AR Core implementation is just an exploration right now to explore what's possible and what might be potential web standards, but there are also a lot more web implementations. For example, Mozilla has their Web XR standards proposal, which there's a lot of commonalities between the different pre-standards proposals right now, so that's a good sign that things are starting to align, and hopefully we have some standards soon. There's also the Argon browser and Argon.js, and I think one of the most popular ones might be the marker-based AR.js. And if you recognize the markers from my earlier slides, it's because it's based on AR Toolkit, so it goes way back. So with all of these standards that are not really fully in place, why should we care about it now? Like, what if it changes? And stressing you guys out to learn all these new things. But as you know, with 3D modeling, it's a really big concept to grasp, and if you start learning it now, like there's a lot to catch up on. People are already using Three.js and have been 3D modeling for decades, so it's really good. If you're interested in it now, then you should start equipping yourself with the basic knowledge to get started. And people are already building really cool stuff right now. So some sources of inspiration, there's some ARCore specific examples on thisisarcore.com. There's also an ARKit version at the bottom there. And one of my personal favorites is this one from g.co/AR experiments, which just features some of Google's, I mean, not biased or anything, but some of Google's AR experiments. But one of the reasons why I love it so much is that half of the experiments on there were created by women. So that's really awesome to show that representation in the WebXR community. And going back to Ivan Sutherland, the Harvard professor who created the first head-mounted display, he said that the screen is a window through which one sees a virtual world. And the challenge is to make that world look real, act real, sound real, and feel real. So with all these technological advancements in the past century or so, I think we're getting really close to that. And although we might not be close to these really complex head-mounted displays that can control an armored suit or anything, I think it's really exciting that we're getting really close to building web-based AR applications, because that is what's really going to make AR become more widespread. So thank you guys for listening.
Thank you so much, Riza.
Thank you.
I have a question for you on AR. Well, I mean, I just want to get your kind of viewpoint on what you're most excited about on the types of experiences that users will get from, web AR.
Yeah, I mean, I'm really excited about web AR because it's going to really open it up to the public or to more users. There won't be the barrier of entry to have a specific device or well, I mean, it has to be one of the compatible devices, but they won't have to download the specific app, and it really just opens up the possibilities. But some of the use cases that I'm excited about is education. We currently have the Google Expeditions, which was formerly just like a VR classroom experiment, but they've expanded it to AR so that kids can use their phones in class and kind of see volcanoes erupting on the floor or learn about planets and see them in the sky. And I think that's a really good way to learn interactively.
Mm-hmm. Awesome. I'd like to see that in the classroom someday in the future.
I wish I had
go
that
back.
when I was a kid.
I would go back in school.
Definitely.
Awesome. Thank you so
Great,
much.
Thank you.
Our next talk is also another creative talk. It's I think it's I mean, it was previewed earlier in the intros. But it's the paint splatter technology that's being used right now outside. So it's by, I don't know if I'm going to say this right, Haltor and Thorthur. I'm sure I failed that miserably. Are they here? Oh, I think that's them. Hi. Hi. Nice to meet you. Nice to meet you. They're going to talk to us about the colorful paint dripping technology that's all over Harpa's concert hall right now. Vandalism without consequences, and how they turned Harpa into a giant LED lit facade, into a collaborative artwork that can be used by everyone. They make up the two-man digital art studio that is Staffly. Is that right? Staffly. Together, they've created a few interactive art installations, and their most notable works was the one that's outside that's utilizing the LED facade of Harpa. So while they set up, help me welcome into the stage Haltor and Thorder.
Hello, welcome. My name is Halldór Eldjárn.
I am Þórður Hans.
And we have worked together on a few interactive installations, and yeah, like was introduced, we are the art duo Stabli. It's somewhat like our band name or something.
Yeah, it means stack in English.
I'm gonna begin by telling you a little bit about myself. I have a bachelor's degree in computer science, a BS in CS, or a bullshit degree in Counter-Strike, like I like to call it. And I work as a freelance audio and an art programmer, but also do my fair share of websites and whatnots. My second job is as a musician. I compose music, and I also am in a band called Sigur, which you should totally check out if you haven't already. And then I also collaborate with other musicians, currently with Ólafur Arnalds on a new generative robotic piano project. Some of my work is most notably the Poco Apollo. It's a generative music piece, and it's written in JavaScript. It uses the photos taken during the moon landings back in the 60s and 70s as an input to a musical engine, and creates sort of soundscapes for the images, so you can flick through the images in a random order and listen to ambient music that is being generated in the browser. And another project is the Infinite String Quartet, which is a modular string quartet written by my brother Úlfur Eldjárn, who is a composer. And we created like a interactive version of it that runs in the browser, and you can select modules or clips from the string quartet and arrange them in a 3D space around you and create your very own version. You can play for hours in creating creepy string quartet music with this. And yeah, then the project I'm working on with Ole, here we are contemplating how to make it sound more like a flower, you know, artists. And yeah, that is being released very soon.
I am Þórður. I am merely a developer. I also have a BS degree, but no joke about it. I work for the local contracting company Gangverk. And I'm also going to use the opportunity to talk about some of my projects, since I have this platform. One recent one I did, this is a vegan Chrome extension. Woo! So it basically takes all non-vegan words, meaty words, and replaces them. Here we have bacon, and that gets replaced to Kermit's wife of 40 years. Then recently, just earlier this month, me and Halldór, we did another Harpa project using the facade outside. This was done for the foundation Go Red, and there's basically a giant heart projected over Reykjavík, where the input is users' heartbeat, heart rate.
Yeah, so let's talk about Paint Splatter. It's an interactive installation where you can participate on your phone. And the simplest way to describe it is that it's a giant shared digital canvas made out of Harpa's huge LED facade. And anyone with access to internet and a smart device or a computer can interact with this canvas by splashing virtual paint on it, which then drips straight down or sideways depending on wind, direction and force. Take it away, Þórður.
Yes. So when you're creating interactive art, it's really important that the user input is simple and rewarding. In this piece, we utilize the fact that most people like vandalizing, especially without any consequences. Anonymously splashing paint on Iceland's most expensive building seemed like a pretty rewarding and simple way to be an outlet for that kind of behavior. For the first few days, we had thousands of visits, both from people all over the world and some people standing outside in the storm, splashing for hours. The reason why it became so popular is how interactive it is. The fact that by pressing a small area on your phone results in a giant blob visible to all participants from all over the world is the key to making this all work. It's also pretty visibly pleasing. The blobs have a well-defined look, and the user input is greatly limited. This way, we could avoid making this look like a giant shared Microsoft Paint document. We could also avoid mankind's most drawn figure on any shared platform, the phallic symbol.
And how we built this thing, the design process was very straightforward. It just started with conceptual sketches on paper, like all good ideas start. And the whole concept was then thoroughly determined before we started coding anything. So that helped us really keep things in scope, and we did one thing well, I believe. Next step was doing some web mockups, just to get a gist of how the animation would look like. And I'm going to show you a code pen I did here.
This is not the code pen.
No, this is my home. This is where I live. I used to keep this on my screen. Yeah, here it is. Here's the first, somehow crappy interactive, and with input parameters, how it would leak. Yeah, just to get a sense of the rendering and main obstacles. This took like 30 minutes to do. So and it was so good to have this with the project proposal. Okay, back to the presentation. The biggest unknown factor in the whole project was how to render stuff on the light facade of Harpa, but fortunately it had been done before, so we just got access to some Node.js rendering server code written by Owen Hindley, which we could fork and adapt to our taste. And the networking part was also pretty straightforward. We just used Socket.io and set up a small app on an Heroku instance that handles all the events to and from users. Like you press and make a blob and it sends the event to all connected participants. And it also contains some rudimentary game logic and input sanitizing and event throttling like you would do. So,
yes.
When we set it all up, we faced some real-world problems.
Since the render server had to be located in the basement with the rest of the LED controllers, that meant we had to go up and down endlessly in our feedback loop. And this is a video of one of those times. But it was a great physical exercise, like a good contrast.
And we also got lost a few times. Like there are thousands of. Harpa is like Hogwarts school.
Yeah.
It's almost always changing, and
I think there are a lot of people like stuck down there.
Yeah, it probably is like a small population there by now.
Yeah, and since this was already online, we wanted to allow more people to participate. So we decided to set up a live stream, and with a very limited budget, we borrowed a phone and we kind of duct taped it to the ceiling of the hotel lobby next, across from Harpa. this worked out great. We got a lot of traction on Reddit, but pretty soon people started complaining about the tourist bus that was always blocking the view, like every half hour or so. And also the staff at the hotel, they weren't that pleased with this unidentified phone that at some point was maybe possibly broadcasting their conversations through the internet.
Yeah, and we also encountered some problems with deploying the render server here in Harpa because we had to connect our computer to 6 unmarked Ethernet cables through a selection of routers and adapters, which had to be done in correct order for it to work. It was most definitely not a very atomic deployment process and felt almost like programming the ENIAC or making punch card programs.
So yes, we had also become like a small TV station. So
yeah.
this was
we had to fulfill our duties as a 24/7 live TV station. Did you already mention the main complaint from the Reddit users?
What's that?
So there was a tourist tour bus. Yeah.
You're not even listening to me.
And then we got spammed. It was bound to happen. Somebody found a way to circumvent our rate limiting. Oh no! And why am I even telling you this? All programmers and JavaScript. And then we got like properly hacked. Now this is actually a very funny story because somebody found a way to override our color scheme. We had like a very limited color scheme. You could not draw black, for instance, so you could not like clear the screen or something like that. But somebody found a way to override it and was suddenly able to draw arbitrary buffers of images by just splatting paint very fast with a for loop. And we knew this was a possibility from the start, but didn't have the resources to prevent it, and except for some basic rate limiting and exponentially increasing backup periods. But this was actually a very fun challenge, and war was upon us. Iceland is very small, and the communities here are even smaller. And the proof for that is that I just got on Messenger and guessed who the hacker was. And this was nota bene before the hacker started writing his name on the facade. And I was right. The hacker was my former computer game programming teacher at university, and he's also a programmer at CCP. And the only person in Iceland I knew that would be able to do such a thing and invest the time to do it properly. So we could immediately recognize his way of doing the hacking because it was very professionally done. We approached him, and after a few hours of negotiations, he surrendered and told us all about how he did it. And he even sent us all the code and a lot of comments on our code, which was very fun to read. So he was able to like draw arbitrary buffers with paint, and this is from his code where he has like neatly organized his name in a proper two-dimensional array. And he wrote a whole rendering server that was running on his computer that spammed our server with paint blob events and enabled him to do this. So he was like rendering on a rendering server on a rendering server, because we all like rendering servers, right? But we made it harder for him. We just increased the rate limiting a bit and added some extra throttling, and without degrading the experience of the normal non-spamming user. And this fight was ongoing throughout the duration of the display. He also was able to avoid, because the paint leaks, and if you draw something, it won't stay there forever because it gets the paint leaks and
Analysis.
somebody else paints over it.
Mhm.
But he added a skewing factor. He could tune to his taste to to be able to create like very straight images. And then we added random noise to it to decrease the resolution of what this hacker was able to draw. And this is still in the code. You see it if you press the Harpa. If you splat paint,
Yeah.
you can see that it
Doesn't come in the center, like where you clicked.
it doesn't come exactly in the center of where you clicked. And also, it's totally on concept because splatting paint like with some paint blood, that's a very unprecise art. So yeah, it's just a part of the concept.
Yes. If you spend some time in Iceland, you quickly learn that the weather here is quite unpredictable. And when we did this the first time, which was in 2016, there was basically a crazy storm throughout the whole time it was up. And that was a great way to show off the feature that we were using wind force and wind direction to render. So we just looked on the bright side. There weren't a lot of people like outside trying this out, more people on the internet. But the year after, we set it up again, and the weather was way better, just nice weather and almost no wind at all, which proved problematic because every time there was absolutely no wind, our render server crashed because we were somewhere in our calculations, we were dividing by a 0. And for the first time this happened, me and Halldór, we were gonna be on live television. And this happened like 5 minutes before that happened. As you can see in this picture, here's the mayor in 2016, loads of wind. You can see his hair, it's crazy. And 2017, this is like a frozen render server, absolutely no wind. Me and Halldór somewhere in the back having a panic attack. But we somehow got through the interview with like demonstrating how this worked without it actually working at all. And nobody seemed to notice, which was a pretty good thing. Yes, we learned a few lessons through this whole process. First being that we should avoid at any means any ribbon cutting ceremonies by politicians with like huge scissors. Especially when it's on live television. Secondly, you should always allow for the weather, even when you're writing code. Even if it has nothing to do with the weather, you should do it, especially here in Iceland.
And it's always fun when your work is worth hacking, at least when it's not done maliciously and while it's entertaining. This piece revolves around the concept of vandalism and that everybody gets their say, everybody can participate. So programmers with the programming skills, they can of course participate, but if you intend to do so, please behave yourselves. We don't have the money to fight you. So, thank you so much for listening, and the piece is accessible at paint.jsconf.is or just paint.is. It's been a pleasure talking here, and we would like to know if any of you had any questions. We are happy to answer. Yeah, the question there. Yeah. The insights of how many users and how many users at the same time have used this. The night when it went live on Reddit, we got like, I think 7,000 hits over a short period of time. And that was after we set up the live streaming cam.
Yeah.
So even if you were abroad, you could splat paint and see a live stream of it actually happening.
Yeah. For some reason, there wasn't like a huge spike at one point. It was like pretty even. I don't know why.
Yeah, and the log file from the server was around 300 megabytes, if that tells you anything. Any more questions?
Oh yeah.
Yeah, we did one a couple of weeks ago, which we told you about briefly. It's a we connected a heart rate sensor to heart animation on front of Harpa, so you could come up to the second floor and make it sense your heartbeat, and then ripples would form that blended nicely on the light facade.
Yeah. And we allowed for 0, but no one had 0 heart rate.
Sorry?
No, it was it was taken down.
The webcam was taken down because the hotel manager thought we were spying on some guests at the hotel.
And our friend needed his phone back as well.
Yeah. Poor guy.
But if you have a phone, you want to like borrow us.
We'll take care of it. Just ask away if you have any questions.
I think so. That's all.
What is the timeout? Is like 2 seconds, 4 seconds, 8 seconds?
What?
No, okay. That was a silly TCP joke. Sorry, I'm very sorry. Thank you so much for listening.
Thank you. And I think their talk is also a perfect segue into our next talk, because the next talk talks about security and how to, protect your web apps. So our next talk will be Dominic. If you can come up on stage so we can set up. Dominic is a developer evangelist for Twilio in Berlin. He's passionate about JavaScript, hackathons, teaching, and also good whiskey. And you'll usually find him speaking at conferences like this, or meetups, or mentoring in hackathons. He's going to be talking to us about XSS, so cross-site scripting, CSRF, CSP, JWT. Well, I mean, this is the title of his talk, and it says, "What the fuck? I don't know." So if you can come up on stage, just set up. I think we'll give Dominic a few. Oh, okay. I think I see him. There he is.
So have you found Dominic? Yeah, he's over there.
Dominic's right there.
Okay, should we then start a bit earlier, or? Maybe we should just wait a bit. I'm gonna sync with Vanessa and the other hall. Maybe like 7 minutes.
Yeah.
I'm fine with this.
I'm just gonna spit out some random Icelandic trivia that I've learned from just looking up random Icelandic facts. Because I've never been to Iceland, and this is my first time, here, obviously. So one of them is that apparently there's an Icelandic naming committee that decides whether your child's name or even your name is a valid name. So I don't think my name is valid at all in Iceland. So I think I'm an illegal name person here. So no one tell the Icelandic naming committee that. Ready?
So we should just go on schedule after 30 minutes. So you can just
30
announce
minutes?
the 30-minute break. Cool. Yeah, because the other talk is also very late.
Yeah.
So just announce that it will start at 30 minutes. Does that make sense?
Not really. So
Because according to schedule, this talk right now is supposed to start in 12 minutes.
in 12 minutes.
Yeah.
Oh,
They're actually cut off on this side, but not the other side. So people like can't, they're in there, can't go and see this talk because the talk is done.
Yeah.
So we need to like see they're starting.
So we can just be on schedule from now on.
Okay, so when are we gonna start?
It's 10 minutes to 3, it's in 12 minutes.
Yeah, so 14.
Just let people know.
So update, apparently we're running pretty early, so we can get a 12-minute break and just come back here in 12 minutes so that we can continue on time.
All right, I think we're ready for our next talk, finally. Hello to the live stream. You must be really confused with all the breaks that we've been having. Anyway, I'm going to repeat what I just said earlier. So Dominic is a developer evangelist at Twilio in Berlin. He's passionate about JavaScript, hackathons, teaching, and you'll also find him normally speaking conferences like this, meetups, or mentoring in hackathons. He's going to be talking to us about all these abbreviations up here and how to protect yourself and your users from the new generation of Bobby tables. So give it up for Dominic.
All right, welcome everyone. Oh, is this mic on? Can you hear me? Thumbs up. Awesome. So welcome everyone. Thanks for joining my talk. I think it's the most clickbaity title. I'm not going to read all of these abbreviations because that already wastes half of the time. But instead, I would like to give you in the next 30 minutes a quick introduction to web security. And this is not going to be making you all web security experts. But one thing that I want to make sure is that all of the topics that I highlight are topics that I think every web developer should be aware of whenever they build an application. And hopefully by the end of the talk, all of these abbreviations will make a bit more sense to you. But before we start, I would like to quickly introduce myself. As mentioned before, I'm a developer evangelist for a company called Twilio. We do things like APIs to send and receive text messages and other things around communications. And I live in Berlin. But there's one more thing that you should know about me, and that's the beautiful part where I can drop this jacket because it's getting really warm. And this is where the talk gets awkward. All right, so I'm a member of a group called Onesie.js. We're a group of onesie-loving JavaScript developers that love to go to conferences and care about the community. I think Flucky is somewhere here, which is the unicorn that is running around. I'm not sure if I see him right now. But like today, we have so many social networks and communication channels, but there isn't really one for onesie-loving developers. So being a developer myself, I did what every developer does when they're frustrated about something not existing. And I built the future great social network called Onesie Live, which is for onesie-loving developers, a social network, which I'm fairly certain will take off. I'm not sure why I don't have high traffic yet, but it will come. And like being a developer, I obviously made sure that this is as secure as possible and doesn't have any vulnerabilities, especially nothing that can be hacked with a banana. So, I thought of everything. It uses HTTPS, and thanks to Let's Encrypt, I don't have to pay a dime for that. It uses HSTS, which is the HTTP strict transport security, which just makes sure that there's no downgrading of the traffic. So this is typically what blocks you from going to google.com when there's a public Wi-Fi with a captive portal, because they're trying to downgrade the connection typically from HTTPS to HTTP. And I don't allow mixed content, so no HTTP content on a website that is served by HTTPS. I sanitize the HTML, so I allow people to put in Markdown, but I'll make sure to sanitize it before I put it in the page. And there's no room for SQL injections because I'm not really using a real database, so there's no way to have database injections. And I'm not talking about NoSQL databases because there are no SQL injections, but I'm literally just using a plain storage because I don't believe this will scale. But turns out that developing secure web applications isn't as easy as I thought. So I contacted my buddy Bob Allison, and he took a stab at the application and kind of and figured out a bunch of security vulnerabilities that I would like to share with you today. And this is where this hood gets really warm, so I'm going to take this off. All right, so if we go to this page, this is basically the login dialog, and I'm going to open the DevTools here so we can monitor the thing. And basically what I'm doing, typing in my super secure password here, and it will just do a normal post request, and afterwards I'll set an HTTP cookie to maintain the session. So if you're not familiar with cookies, it's just a way that allows you to maintain session state throughout multiple sessions by setting a value either via HTTP headers or via JavaScript. So if we go into the console here, we can actually access that. And so I have one that is called auth token. And this is what is called a JWT or JOT or JSON Web Token. And they're formatted in a very particular way. So if we inspect this, we can see it has 3 different parts. It has a header, which is the red part. It has a purple part, which is like the payload. And then it has a signature. So that's generated by an algorithm that is specified in the header using a secret. And if we look here, it actually says invalid signature because I was smart enough to not use secret as my secret. But unfortunately, there is a vulnerability in my app around this that we can exploit. And that is because there are different algorithms that you can use to sign your JOTs. And one of them that is mandatory in the spec is none. And what none basically says is that disregard the signature. We don't care about it. And this is more for like transmitting data than like maintaining session or something. But the problem is if we do this, and let's have some fun, we switch the role here to admin. And then I copy this part. And this is just base64 encoded, right? So this is plain data. Don't think this is secure or something. And I will set this as an auth token. Then we will, we can refresh the page and we'll see that we're now in admin mode. And that is because I'm taking the JOT as a single source of truth. So if it says role admin, I'm an admin. You know, I'm not looking this up or anything. And because of that, in combination with the algorithm that is none, we can kind of just switch anything. And I wouldn't have had to log in the first place. I could have just generated this token with any username and sign in as anyone. So how can we protect ourselves from that? So the first thing is, as I mentioned, you can set cookies either via JavaScript or via HTTP headers. And you can declare cookies as HTTP only. And that means that you can't access these via JavaScript. They will still be sent around by the browser, but you won't be able to access them in JavaScript and manipulate them. Additionally, I should have set this as a signed cookie, meaning I won't be able to manipulate this anyways without knowing this, the token that was used to sign the cookie, and as secure, so this is only transferred by a secure connection. But there's another thing I should have done, and that evolves around JOTs themselves. So I'm using the JSON Web Token library on Node, but I'm using an old version, and that one has 2 flaws that the newer one fixes. And that is, on the one hand, the library should provide you with a way to whitelist algorithms. So in this case, I'm in the secure version of this, I'm saying that I only allow HS256 tokens versus nothing else. And then the other thing is, in this library, for example, if the secret is set to something that is not null, the library will actually not accept none as an algorithm. But that's only in the newer libraries. So the bottom line here is stay up to date because you don't want to be the next Equifax, because that's pretty much what happened to them. Not about JOTs, but about having an older version of an implementation that was known to be vulnerable and them not getting around to update it. So you don't want to be in the news for that. And this is a social network, so we can post stuff. So let's jump back here and actually post something. And I set this as marked, so we can write something like, hi, JSConf Iceland. And if we post this and we look at the traffic, we will see that, if I make this bigger, let's switch this to this. There's an HTTP post request here that actually sends the auth token along and just sends a form data here in the bottom. So this is nice because it's really easy to implement. I'm literally just submitting a form asynchronously. But the combination of form and cookies is also something that can cause a cross-site request forgery attack by attackers. So to give you an idea how this works and what this actually is, so this is pronounced XS. So sometimes it's written as XSRF or CSRF, but typically it's pronounced CSRF. So if we perform a CSRF attack here, it says you got pwned, and if we get back to the page and we refresh here, we see that actually the attacker was able to post on my behalf on the page. And the reason why this works is that the browser is super eager to send all of these cookies along on every request. And if we look at the code that actually hacked us here, all it does is it on body on load, it will submit the form that we have there. In this case, it's visible, but this could have been also just hidden. And inside there's an input tag with a message we want to send. Again, this could be hidden. It doesn't have to be visible. And and then this just submits. So, and this is really the danger about this because the browser is super eager to send this. So let's talk about how we can fix this. So let me find my slides again. All right, so apparently I was hacked twice by this application. So let's navigate back first and talk about what happened here. So when I clicked on the link here, I'm using a target blank link here. And what this causes is that the attacker's page can actually access my page window by using window.opener.location and rewrite that location. So in my case, I was just, the attacker page was just navigating me to another harmless page, but this could just as well be a redirection, for example, to a phishing page that looks like your page. So imagine you have something like a social media page where someone can post a link and you always mark it with target blank. Then someone could put in a page link that redirects that original browser to a phishing page. Luckily, protecting yourself from that is actually pretty straightforward. You want to use the rel attribute and set it to no opener and no refer. No opener basically declares that you don't want to provide access to window.opener, and then there is no refer, which because some browsers don't support no opener, namely IE, and I'm not sure if the newest version of Edge supports no opener, but older versions don't. You want to use no refer as well, which at least will hide the refer URL, so we can kind of protect ourselves from that. Plus, there are some JavaScript scripts that that allow you to kind of circumvent this as well. To get back to the CSRF attacks, the approach here is relatively straightforward as well. You can use a library like CSRF or just implement this yourself. But the basic idea is that you will generate a new cookie called underscore CSRF, for example, where you specify a random token, and then you pass this token once as a cookie, but you also embed it into the page that is supposed to have this, for example, a form submission, into, for example, a hidden input field. And then when you submit the post request, in this case, you will check if the value in the cookie equals the same value that is either passed in the request body, in the request query parameters, or in one of the headers, like the ones in the example, which are the ones that the CSRF library checks for. And if that's the case, then that works. And like you successfully submitted something. If this isn't the case, it's likely someone who performs a CSRF attack against you, because they will be able to submit that cookie, but they're not able to read that cookie since the browser auto-submits this, meaning that they will not be able to pass this as a header additionally. All right, let's talk about Little Bobby Table's younger brother, which I call Sammy. And the reason is to first give you a background about Little Bobby Tables, if you're not familiar with that. It comes from this XKCD comic, which is a joke about SQL injections by a family of hackers who named their kid like a SQL injection, and the principal being mad because they lost all of their student records because they weren't sanitizing the input. Now to get to XSS attacks, does anyone know what this source code is from? I would be really impressed if someone knows this by heart. So this is the MySpace worm, or Sammy worm. Some of you might be familiar with this. For those who are not familiar with this, this was an XSS attack from 2005 on MySpace, which would basically repost this code, add Sammy as your friend, and post that Sammy is awesome. That's also how they caught him, because if your XSS code points at your MySpace profile, that's not a smart idea. Maybe now, because MySpace isn't much of a thing anymore, but especially at that time, that wasn't a smart idea. But the cool thing about this attack is it shows a couple of things that people use to circumvent XSS protection, because MySpace actually had XSS protection, and yet that wasn't enough, because one thing that they said is they don't allow script tags, they didn't allow JavaScript colon in URLs and stuff, but they did allow inline CSS. So Sammy just created a div tag that had a style in it that used background URL and then put JavaScript in there. And because he wasn't allowed to use quotes in there, he basically took all his code, wrapped it into an eval, and put the code itself into another HTML attribute, and that would then just be evaluated. The other thing is they blacklisted words like inner HTML or on ready state change, which is something that is used by XML HTTP requests, so AJAX requests before there was fetch. But what Sammy just did is he just turned this into strings, split them by a plus, and then so basically reconcatenated them and evaled the whole thing, which equals to the same code, but it's harder to regex against that. And then there's the other thing, because if you say that, like, well, I could block eval, and then that's fine. Those are all ways to evaluate code. The last one is from a project that I'm not sure if I can name the name, because I'm not sure if it violates the code of conduct, but talk to Martin Klepper over there, and he can probably tell you the name, or I can tell you the name afterwards. But basically the bottom line here is there are a bunch of ways to write the same code in JavaScript. So you can't just block like a single word or like blacklist certain words, because that doesn't help you. So blocking XSS is not trivial, and obviously I have a demo for that as well. And so I told you I'm using Markdown here, and I'm using a library called Marked. And if you're not on the latest version, but like a few versions back, so not really old, even though it has a function that allows you to sanitize stuff, so we can do stuff like alert 1, and this will not work, there is a security vulnerability in here. So we can create links, right? And I can do something like click me. And in here, if we would write JavaScript :alert hello JSConf, then I'm going to copy this. This doesn't work directly because the sanitizer is smart enough to do that. But we can play around with this, and shout out to Guy from Sneak, who actually showed this to me. Let's do some fun stuff with encoding. So ampersand #51 semicolon is literally the same as a closing parenthesis. And similarly, a colon is ampersand #58 semicolon. And I'm going to copy this. And if we look at this, this is already a difference because suddenly we don't have the closing parentheses anymore. So we're getting there. Now we can use a sort of quirkiness in the browser and actually write this here. And what this will do, let's first try this. It works. And the reason why this works is that the browser, so first of all, the HTML sanitizer will see this and it doesn't see JavaScript colons, so it's like, I'm fine with that. But the browser will see, oh, you have an ampersand, a hash, your number. I think you just forgot the semicolon, so I'll be a good guy and insert this. Then everything afterwards turns into JavaScript. So this semicolon is valid JavaScript, so it doesn't complain about that, and then we can do anything afterwards. So we've seen this works. And the bottom line here is encoding can be dangerous. Don't trust any code that your user can put in because they can just modify it in like different ways to kind of get around that. Also CSS, don't trust CSS. I don't have time to dig into that now, but don't trust it. And Jake Archibald actually just tweeted about this 2 days ago again with a new blog post. Really don't trust CSS. There's a bunch of stuff you can do about it, and I highly recommend you to check out this tweet or like the blog post in this tweet. Let's talk about another thing, and that's JSON-P. So JSON with padding, it's being used less these days, but basically it's a way to circumvent same origin policy. So if you want to request some data from a different domain, you could do this. And the way it works is you define a global function. If you would use something like jQuery's JSON-P method, it would define this for you. But it's basically a callback function that has to be global, where you expect the code to, the data to be passed into. And then you inject a script tag with that JSON-P URL and pass in as a callback, for example, or any other parameter depending on the endpoint. You define the name of the function. In this case, it's called getPosts. And what this will do is the JSON-P endpoint will take that name and then wrap the data into a function call with that name. Now, if you use that, but you write poor JSON-P and combine that with the XSS attack, now this is getting fun, because my JSON-P endpoint does not verify what I pass in as a callback. And that means that we can, I'm in the wrong tab. We can generate arbitrary JavaScript here. And this gets really fun. I'm going to first show it to you and then explain what's going on. So this is a bit of a longer code snippet, so I'm going to copy this. So I'm going to press this and then click this button, and nothing happens. But if I refresh the page, we get this. and I can refresh as many times as I want. It will stay like this. So the reason why this is happening is if we go to application, I installed a service worker. And if you don't know what service workers are, they're an API from the browser that allows you to handle the network proxy so that you can, it's made for things like offline available apps, so you can cache your website and your resources and kind of handle which ones you want to cache and which ones you don't. But it can pretty much do anything because it can intercept the network requests, right? Now the browsers are smart enough to make sure that this can only be, like a service worker can only be installed from your domain. But if your domain has something like a vulnerable JSON-P implementation that allows you to generate arbitrary JavaScript code hosted on your domain, then you have the problem like this. So we can actually see the callback parameter here is really long because it's literally the entire JavaScript that I wanted to generate. And if we prettify this here, we can see what's actually happening. So I'm creating the service worker script, and then the entire data, because I don't really care about it, is commented. And in here, what we do is we just kind of reply always with a hacked and a script tag injected. But this is an obvious attack, but you could do it in a less obvious way as well, right? You could actually fetch the page, inject a script tag, and then send that to the user, and the user will not recognize this. Especially not a common user who doesn't have the dev tools open and checks what service workers are installed. I mean, how often did you do? Let's see, I think they still have that checkbox or something. Oh, it's down here. So there is a drop down here called service workers from other domains. That's a lot of fun. Open that and you will see how many people actually install service workers. But you're not reading their code, so you have no idea what these service workers do. So it's sort of a dangerous attack. Let's actually remove this because else I forget about it. Unregister. So if we reload this now, this works, but you obviously don't want to explain your customers. Please go to your browser and then click on application in the dev tools and then click on unregister on this thing called service worker. So far we've seen different XSS attacks, and we should fix all of these and also all the other attacks that we have in there. But there is a new superhero in town that allows you to protect yourself at least against some of these. And that's called Content Security Policy, or CSP. And I have a demo for that, and this is the exact same page. All that I'm doing is I'm injecting an HTTP header, and we can see that if I click on any of these and refresh, nothing happens, no difference. The only difference is I'm not showing some pictures here. And if we open this and go to the console, we'll see we have a bunch of errors. And that's because it says that it violates the following content security policy. So what does that actually mean? So I said content security policy, it's just an HTTP header that you can define rules that the browser should play by for your resources. So this can be things like, by default, anything hosted on my domain is fine, but for scripts and styles, I only want to have things that have the following nonce. And this nonce changes on every request, so this can't be hard-coded by the attacker. And that means that no more inline scripts unless they have an HTML attribute called nonce. Similarly, no inline styles or anything, and that's why the alert 1 or these XSS attacks don't work. I'm blocking objects here. Image source, I'm only specifying self and api.adorable.io, which is what I use for the user icons. Font source, I only allow Google fonts and self. I block all mixed content, meaning no HTTP content in my page. And then I specify report URI, and this report URI will be pinged on every violation with an HTTP post request. There are tools that you can point this against, but you can also point this against any endpoint on your server, and this will report it. There's also a report only flag, and that one allows you to say that you want to only get the information that something has been violated, but you don't block the actual content. And this is great for kind of transitioning into it, especially if you want to test this first in a local environment or something. But the important thing here is to keep in mind is that CSP should not be your security policy. It should be, or security strategy, it should be your safety net. Because writing a really strong CSP is hard, and there's a great paper by Google about this, sort of about the dangers of this. And meaning you should only have this as a safety net, but you should still care about XSS attacks and similar things. couple of other things that you should look out for. You should avoid clickjacking by disallowing framing. I think most websites don't have a legitimate reason why they should be allowing to be iframed. And if you do allow iframing, what an attacker can do is they can place your page with an opacity of 0 above their page and kind of line up buttons so that that a user thinks they're interacting with their page, but they're really interacting with your page. And so this is what people could use, for example, to like, if you want to like a page or something like that, which like Facebook blocks iframing, but you could do something similar. Also, don't show versions of front-end libraries and servers. So there are things like unpackage and stuff that are really useful to develop things, but if you show a version number in your HTML page or in your HTTP headers, like, hey, I'm using Express version, whatever, this gives an attacker the right idea of what security vulnerabilities to test out, and you don't want to make their job easier. And then check for types of input, because there can be things like NoSQL injections. If you expect a value to be a string in an HTTP, in like an HTTP body or in a query parameter, check that it's really a string. Don't just assume it, because there are things that some parser libraries that will parse things like objects as well. And if you do that, the result is that you could, for example, have a NoSQL injection. Other things, consider security audits, especially if your code base has never had a security audit. If you don't have an internal security expert, contract one, because there's so many things that is really hard to kind of keep up with, that this is really helpful. And you learn yourself a lot as well if you look over their shoulder. That's how I learned most of the stuff, was when I had to go through a security audit with a feature. And then stay up to date with versions, because as I said, you don't want to be the next Equifax. Greenkeeper is a useful tool, but there are other tools as well. Similarly, use a tool to detect security vulnerabilities in your dependencies, because you can write the most secure code, but if your dependencies are vulnerable, that sort of defeats the purpose. So Snyk is one of them. I like them because they also provide patches for things if they're too late. So for example, Marked still has a fixed that vulnerability that I showed you, but they still have a vulnerability about data URIs, and that still didn't make it into the package, at least last I checked. But Snyk, for example, has a patch for that. But there are other tools like Node Security Project and etc. that check for this as well. GitHub, I think, scans your package JSON now as well and tells you about vulnerabilities. So to wrap this up, use signed HTTP only cookies. Be skeptical of JOTs. Don't treat them as a single source of truth. Use something like, use rel no opener and no referrer on your target blank links. Use CSRF tokens. It's really easy to use, so there's no real excuse to not do it. Blocking XSS isn't trivial, so always think about, like, whenever you let the user input anything, or if you have query parameters or something, always think of these and make sure that they can't cause harm. Be aware of encoding, because there are a million ways to write the same thing. Be careful with JSONP. A JSONP endpoint should really only accept word characters in a callback and nothing else. Use CSP as a safety net. And most importantly, stay up to date. So I put up the slides here, and I'm going to tweet the link in a second so you can check them out again. Similarly, the whole source code of the website is on this URL, including different README files for every of these vulnerabilities that I showed you, plus a couple of others that are in there, including resources that are interesting about the respective topic. And with that, I would like to thank you all for your attention. I'll be around for the rest of the day wearing likely this jacket instead of the onesie, because this is really warm, even in Iceland. And yeah, come by, ask me any questions, and thank you for your attention.
Thank you so much. I have a question for you.
Yep.
So what do you think we as software engineers can do to advocate in our own companies to actually do more things for security?
I think sort of highlighting past examples, and there's a great talk by Asim. He's Jawache on Twitter.
Mm-hmm.
He has a great talk online that talks about like different instances of where people were hacked because of different security vulnerabilities, and sort of showing these things backing them up helps serve. Like, you don't want to be in this situation, right? Like, security is a preemptive strategy. Like, you should always have security in mind, because if you have to think about security because of an attack, it's too late. So you always should think of this ahead of time.
Awesome. Thank you so much. Again, Dominic. So we have a break for 30 minutes. So go get your coffee. I think I need coffee. My body thinks I'm in New York still. So yeah, head out and come back in 30 minutes.
binding.
I don't wanna die for them to miss.
No, hello. Okay. Hello, everyone. Welcome to our lightning talk, part of the event. So it's going to be 7 lightning talks, and we're going to be starting with Andy. So I actually have a timer on my iPad timing them, so we're kind of a little bit strict about it. So here's Andy talking to us about TypeScript. Yes, awesome.
Hi, I'm Andy, and I work at Shopify. We're an e-commerce platform, and today I'm going to be giving you a whirlwind introduction to TypeScript. So first, a brief disclaimer. Most of the stuff I'm going to talk about today is TypeScript specific, but TypeScript is not the only way to bring types into your JavaScript. There's a lot of other really good options. I actually first started with Flow, and then we switched to TypeScript at work, and so that's what I do most of my time, but Reason or Flow or TypeScript, they're all great. Okay, so first I want to give you a little bit of why to use types. This is probably the most important part, and then we'll dive into some TypeScript syntax to hopefully make it a little less scary to get started. So I really want to talk about 2 main reasons that you would want to use types in your project. The first one is that if you're working on a large application, as that application grows, it's impossible to keep in your own mind everything that's happening. So if you're working on a small library, like maybe the overhead of types is a little bit overkill, but if you're working on a really big application, eventually it's going to get to the point where you can't keep track of all of the changes that are happening to functions or other interfaces in your application, but the compiler can keep track of that. So it's like having this like super powered buddy on your team who's going to keep track of everything that's happening. The second thing is that it's really hard to keep documentation up to date, whether it be comments in your code or whether it be a README or whatever else. The nice thing about types is that they make your code a little more self-documenting, and since the compiler is going to be enforcing those types, it's a lot harder to get them out of date. It's definitely possible, and it's definitely easy to do things that still make it hard to understand, but it's a little bit of a help to make your code easier to jump into. All right. So basic types. We're going to start going pretty fast through TypeScript syntax here just to kind of do an overview. So here is like sort of a hello world of some very primitive types in TypeScript. You can see that it looks a lot like normal JavaScript, but you have a colon and then the name of a type, which is how you're going to annotate your variables. Now, that actually isn't necessary a lot of the time. I would say that I, more often than not, don't have to add explicit annotations to my code because TypeScript is very good at inferring what I mean. You can also see here, this is where the benefit starts coming in. So this screenshot is from Visual Studio Code, but it's really just a reflection of the error that the compiler is outputting, so you're not tied to using VS Code with TypeScript. But you can see it has a red squiggly under this index of call because a Boolean doesn't have a method called index of. All right, so arrays, this is a little more complicated, but looks much the same. So you have an annotation, and you just put square brackets after it to say that it's an array. So you can see here, I have this array of foods, and if I initialize it to these strings, it's happy. If I push in a new string, it's still happy. But if I were to try to initialize it to an array of numbers, or if I were to push in a Boolean, it's going to complain at me, and I would have to fix that. Functions, so this is where things get really exciting. So your functions, you're going to be importing them all over the place in your application. Before, those were like pretty contrived examples because like you can look at your variables 3 or 4 lines above or even in the same file. But a function, this is where you're going to be able to catch things across your whole application as you import things. So you can see here that I typed my parameter with that same annotation. There's another annotation after the arguments list, which is the return type. And then we just write normal JavaScript on the inside. So if I pass it race car, it's going to be happy. But if I pass it a Boolean, then it's going to complain. Again, TypeScript is pretty smart at inferring what my variables are going to be and what my return types are, so we can actually omit that return type if you don't want to do so much typing. All right, unions. This is, again, a little bit more of an advanced feature, so you can think about a union like an OR. This is something that I use all the time. So here, like, I want to say that a vegetable can be a broccoli or a carrot. I say that fruit can be any of these fruits. And then I can also use unions with types. So I can say that an ingredient for this restaurant is going to be either a vegetable or a fruit, and it can be any of those values. So then if I'm making a recipe for juice and I give it broccoli and watermelon, it's happy, but if I try to make this sludge drink out of bread and bacon, it's going to be very unhappy because that's neither a vegetable nor a fruit. All right, interfaces. This is going to be our last type, and then we'll go through a short little example. So interfaces, this is how you type objects. So this looks a lot like plain object notation. You have a colon, and then instead of the value, you put your type name. You also can use all of these other features inside of your interfaces. So here we have a union between a bunch of animals. You can have your favorite animal. You can make it optional by allowing nulls, and then TypeScript will help you check null before you try to access those values or anything like that. All right, so most of my day I spend writing React, and that is like where TypeScript really shines for me. I like it pretty well when I'm writing plain TypeScript, but for React components, I think it's the bee's knees. So here we have a really simple example. If you've used the prop types package, this probably looks very familiar to you because in prop types you also have to like declare your props. The nice thing about this is you get a little more help from the compiler and it happens at compile time instead of at runtime. The other nice thing is that you don't have to include the prop types package. All of this gets stripped out at compile time and then you ship a smaller bundle a little bit. So just to walk through this, we have our props. We're going to have one prop called size that accepts either small, medium, or large. And then we just pass it into our component as usual. And you can see here that inside my component, I have very little TypeScript-specific syntax. It really looks pretty much like normal JavaScript. And then this is what it looks like to use that. So I import my icon component, and if I don't give it any props, TypeScript is going to complain to me because I told it that I was expecting some props. Here, if I give it size, it can suggest to me what those props should be. So this is really nice when you're like using a design system inside your company because you can know exactly what the values are supposed to be. Again, this is the VS Code interface, but when you run the TypeScript compiler, it gives you this exact same suggestion where it'll list what it's expecting. And if I give it something that it's expecting, it will be happy and it'll compile my code and I can run it. So I hope that has made TypeScript a little less mysterious. You can find me at AS Mokler. Thank you very much.
Andy was right on. Hello? Hi. Andy was right on the dot on that timer. It was awesome. So our next speaker is Burke, and he's going to be talking about, it's titled, The Best UX is No UX at All, or No UI at All.
That's enough. Sure.
Yeah, there you go.
Is this it? This is my clicker?
Yeah.
Has it started yet? No?
Yeah, the clicker. Is it the right clicker?
What do I do? Just go to the right?
Yeah. This works.
Again? Wrong slides.
Sorry?
Wrong slides.
Wrong slide?
Yeah, different slides. These are good slides, though. Should I tell a joke while we wait? I don't know anyone. I don't know any jokes. Help me out. Let's see. A good book is like a puppy. Easy to pick up, hard to put down. Oh, see, I told you I didn't know any good jokes. You forced me into it. I didn't even want to do it. Please hurry. Okay. All right. Did we start? Oh, thank you. That's it. I'm done. Can I go? Did it already start? Tell me when to start. Now? Okay. Hi, my name is Burke, and I love user interface. I have always loved user interface. I remember staring at the glory that was compact tab works while I played this game called The Incredible Machine and listened to the Tears for Fears Greatest Hits album. Now, don't judge me. I was listening to Mad World way before that Donnie Darko and that Creepy Rabbit movie. That's an old and obscure reference. You may not get that. That's okay. What I'm trying to say is, it's not you, it's me. As Costanza would say, that's another old and obscure reference. You know what? Forget all that. Let's move on. I got my first computer when I was in the military, actually. I was in boot camp, and they pay you in boot camp, but you can't spend the money, because you're doing push-ups and stuff. And so after I got out of boot camp, my dad encouraged me to buy a computer. So I got my first computer. Oh, you can see the slides right here, which was a compact HP Pavilion. It looked just like this. And it came with Windows 98. Oh, my sounds aren't working. Yeah, there we go. And I loved Windows 98. I spent so much time just changing the themes, the different themes, looking at the icons and the text. I mean, each theme was better than the previous theme. It was incredible. It was so good. And if only I had known then, if only I had known what was coming, if only I had known about Windows XP. Okay. This was, do you believe in love at first sight? Does love at first sight exist? No, of course it doesn't. Don't be ridiculous. Love is a very complex human emotion. But let me tell you what does exist, infatuation. And I was infatuated with Windows XP. I mean, the curves on the start menu, the blues and the greens, the way the windows are layered in space, it was beautiful. I know it's weird, but I wasn't that socially popular, so I had a lot of time to sit around and do weird things like stare at an operating system. And then this spawned a big hacker community and a lot of tools to skin Windows XP. And when you can do that, obviously you want to make it look like OS X. That's the first thing you do. So this one goes out to Starduck. Now, as much as I love UI, I am not a designer. As much as I want to be a designer, I am not a designer. He's a designer. I'm not a designer. Now, what I can do is assemble building blocks. So if you give me sliders and drop downs and modal windows, then I can build you UI. And I used to work for this company called Kendo UI, and so I've been fortunate to be a part of some great UI products. But you wouldn't hire me to build a website for you, okay, unless you were my mom. Otherwise, you're not going to hire me to do that. That would be subpar results. And so what I've realized through all of my time working with UI is that really the best user experience is no UI at all. So let me talk about that for a second. UI is kind of a middleman. It's a conversation, it's pre-canned, and it has boundaries, right? So we try to code for the simplest possible scenario to get a user through the process or all the processes in the world, right? And we could improve upon this UX probably a little bit. Now, there's been some great feats of UX genius. I'm still a fan of skeuomorphic design. If a baby can pick up and use an iPad without any training, that's kind of an amazing thing. Now, that said, the reason why we have UI and these wonderful buttons and sliders is because historically, we haven't been able to talk to computers until now. Natural language processing is the field of computing that deals with not just speech recognition, but extracting a user's intent from what they just said. You may be familiar with this in a couple different forms. We have Alexa, Cortana, Siri, and Google Home, or OK Google, or Google Assistant, or whatever the heck you call that thing. A lot of people have these. Now, I'm going to give you 3 examples of how I think no UI is better than a UI. The first one is creating reminders. So I can say, hey Siri, remind me to email my mom. And that experience is way better than going into the Reminders app and doing this. No matter how beautiful the Reminders app is, it will never be as easy as me just saying, do it. Another one is home automation. Here's an example of me turning lights on and off with here's the app that you do it with. So here's me turning lights on and off with the app. Very nice. And now here's me doing it.
Alexa, turn on the master bedroom light.
I can barely hear it.
Okay. Alexa, turn off the lights in the master bedroom.
Now watch this.
Okay. Alexa, can you turn on the master bedroom lights?
Okay. And that is natural language processing, right? I completely botched that command 7 different ways, and it still was able to pick it up and do it. You know what's even better is if you have a Nest thermostat, you can lay in bed and control the temperature with your voice. And now that I've said that, it sounds really pathetic. You know what? Never mind. I don't ever do that. The last example I'd like to give you is a service called Digit. Digit is a remarkable little service that saves for you using machine learning based on your spending patterns, and it will give you savings updates. I blurred this out so you don't get too depressed by my low balance. And the whole interface is conversational. So it has an app now, but before, all you did was chat with it to save, to withdraw, and it was pretty resilient at understanding my commands. I didn't have to know what to say, I just said it. And I thought that was quite remarkable. So the question now is UI as we know it dead? The answer is no. No. Absolutely not. There are accessibility concerns. You wouldn't want to take photos with your voice. You wouldn't want to scroll through pictures with your voice, right? Like scroll up, scroll down, that's not a good user experience. But it does give us a chance to rethink some of the ways that we build UIs, that maybe we don't need to build a UI, and instead what we need to build is something that's more conversational in nature that uses natural language processing, because that's now available to all of us. And if, I'm gonna end a little bit early, several seconds early, you can check out the Lewis project here. This is a completely free tool. It's a visual interface you can build, and then as long as you know how to make an AJAX call, you can add natural language processing to your applications and or build a bot or a conversational UI. Thank you so much. Sorry, I think the mic's sweaty.
Oh no, that's totally fine. Thank you. I just want to acknowledge my co-MC. We're the same. We use they them pronouns. I don't really know its name yet. We're gonna be friends in a minute. Bela.
Their name is Bela.
Their name is Bela. So our next talk is Istvan. He's gonna be talking about a talk titled 2,560 bytes. Is ought to be enough for anyone.
Perfect.
Awesome. Thank you so much.
Good to go. Thanks. Yeah, that clicker is. Oh, there you go. I'm just not going to be running around. Yay! Hi, JSConf Iceland. So, as Ferreira has introduced, my dear co-presenter is going to be Bela for today. You could see them holding yesterday's beer, which they enjoyed very much. So we're going to be talking about 2,560 bytes is out to be enough for everyone. If you don't get get this reference, you probably are pretty old, or you just watch a lot of memes on the internet. So my name is Flaki, which is the short for Istvan Smojanski. I'm from Hungary, or at least I still rent an apartment there. I work basically doing DevRel and a bunch of other new modern technologies. I'm a Mozilla tech speaker. I've worked with the Mozilla DevRel team doing the same thing. And I'm doing a bunch of JavaScript or microcontroller stuff and hardware in general. So I'm a member of the Tessel project, which is basically what brought me into hardware in the first place, like 2 or 3 years ago when this thing went on. One of the crowdfunding campaigns, I ordered one, I started playing around with it, and did my first presentation in Budapest on a JavaScript or microcontrollers, and basically convincing people that running JavaScript on a microcontroller might actually be a good idea, or at least not being a terrible idea. So why would that be? I'm not sure this talk is going to sell it to you, but actually one of the creators, John McKay, has given a talk last year at Web Rebels, talking about the whole journey of the Tessel team. There's a reading list you should read up on this. It's fascinating how they use JavaScript and not really use JavaScript on a microcontroller. And there are other devices like the Espruino that you see on this screen. This is like the thing that you see is an USB connector. So this is literally a thumb by size, and you can program this with JavaScript. It had a very strange JavaScript compiler, like JavaScript engine running on it, and Samsung didn't think that was okay, so they set out to bring JavaScript properly onto microcontrollers. To be honest, like the Espruino has improved a lot since, so Espruino is also a very capable chip by now. But what Samsung came up with, and eventually open source, is JavaScript, which is it powers a lot of devices. You can program, for example, BBC microbits on it. So it's a pretty interesting stuff happening. And I forgot to set this up. So let me just set some. Hopefully, yep. No, not yet. Or okay, that's not good. Why is it not working? Technical difficulties, I guess. All right, we'll see if we can get this to work. Nope, not that one. There you go. Now we're talking. All righty. So let's talk about a bunch of more interesting stuff, like JavaScript-powered IoT. Just 2 years ago, here on this very stage, maybe on this exact stage, Pebble announced that they are actually running JavaScript on their Pebble watches. And they actually didn't stop until they could get JavaScript running as fast and as battery efficient as they could run C code on the microcontroller. So you can see 230 lines of codes versus 39 lines of JavaScript powering the UI of a smartwatch. And when they won Defunct last year, they actually got bought up by Fitbit, and my watch is actually running JavaScript on the UI, so you can actually create apps and stuff for your watch on JavaScript. But we need to go smaller. Like, these are pretty capable modern chips, so how about putting JavaScript on the microcontroller like this? Have you ever played with Arduinos before? This is a 8-bit processor. This is an Arduino Micro. It literally has 2,560 bytes of memory. It holds 30K of flash, and you can do stuff like put Space Invaders on it. How? Well, there are a bunch of ways. Usually you use the Arduino IDE and some C or C++ to code it. I created a small project that you can do this with JavaScript. And it actually turns your JavaScript into C++. It's a good thing Andy just mentioned Flow. It actually uses Flow in the backend to infer your types and stuff. I don't have time to explain it, but if you want to, just come up to me and try it yourself. And because that's all the games that you're going to be making are going to be just JavaScript, you can just put them onto the web and play them. And after you played them, you can compile them and put them onto devices like this one. So this is a JavaScript game running on a microcontroller, compiled for a microcontroller hardware that has a 8-bit 16 megahertz processor. And if that's not enough, you can use this one, which is literally a tiny arcade. That's the name. It's a tiny arcade box that you could play with. Why is that interesting? Because this is just the web. This is just JavaScript and Canvas you're writing. And you can check that because I have some links up. If you go to this with your computer or your laptop, actually you can play the exact same game that gets compiled down to the microcontroller and the gaming devices. We have Space Invaders if you're into that kind of stuff. And we also have a workshop. So if you're Icelandic or if you're going to be driving around the island for next week, just drop by Reykjavik University next Saturday, and we're actually going to do a whole workshop. The creators of these devices actually were kind enough to provide us with a bunch of devices, so you can actually play with JavaScript, create games, and put them onto a microcontroller and play around with those. And next Saturday, there is a link in there as well. And if you want to talk about these kind of stuff, at me at Twitter at SLSoftworks, or follow at Cloudboy for the new stuff. All of this is open source. Most of this is built on Node.js and JavaScript, so the whole server and whole editor is all based in JavaScript, so you can contribute if you want to. And all the slides are online at talk.flag.is. Yes, that's an Icelandic domain, right? /play/JSConf Iceland. So thank you very much. There's a reading list and links if you want to know more about these topics.
Thank you. Our next talk is from Martin, and he's going to be talking about accessible, customizable selects, and it's probably harder than you thought.
Thank you.
Give it up.
Hi. Okay, this is working. Great. Welcome to my presentation about accessible, customizable select. My name is Martin Jurča, or you can call me Maťo, whichever you like, and I work as a front-end developer for the Seznam.cz, a Czech company. Now, let me address the elephant in the room. Why another JavaScript select? After all, isn't it the first rule of ARIA accessibility that we should always use the native select whenever possible? True, however, the native select is very hard to style using CSS. This forces us to create our own custom implementations, and we need to re-implement the accessibility into it as well. And I'm not talking just about high enough contrast and large enough fonts. What I mean is supporting properly assistive technologies, such as the screen readers used by visually impaired. And since this is obviously a hard problem, there must be plenty of existing solutions that are out there. Well, I have looked into them. I have reviewed and tested various existing solutions provided by various companies, also various techniques that are recommended when one needs to implement their own select element. Unfortunately, there were some issues. For example, the implementation provided by Google as part of the Polymer project is not compatible with JAWS and is quirky when used with voiceover screen readers. So how can we use such a solution? We cannot. On the other hand, there's implementation by jQuery UI, which is buggy with plenty of screen readers and remains completely silent when used with voiceover. So how can we use such a solution? We cannot. To make things worse, we were actually looking for a solution that could be integrated into any project regardless of its front-end technology. But of course, accessibility was the top one priority. And what do I mean? We were looking for a solution that works regardless of the operating system the user may be using. With slight reservation, so when it comes to Linux, since its support for assistive technologies is not as great as it could be. Next, we of course must support all the commonly used browsers, including Internet Explorer 11, though it is favorable if the technologies used by the solution would be polyfillable for up to IE8. As hinted before, support for all major screen readers used around the world is a must. And of course, we cannot forget about the myriad of keyboard shortcuts that are supported by the native select element. Don't worry, we don't have to consider all of these combinations of all these technologies equally, since there are some combinations that are recommended by the providers and vendors of these assistive technologies. It doesn't mean we can ignore the rest. We just need to make sure that these work really well. On the other hand, there are some combinations that are just not compatible at all. For example, the JAWS screen reader is incompatible with the Edge browser. I'm told this is being fixed. Anyway, all of this has took us on several months of a journey in which we were testing and prototyping, and we made quite a couple of findings. For example, the accessibility support in browsers could still be improved, and support for ARIA, which is used to make our websites more accessible, and is implemented by the assistive technologies, not the browsers, is implemented inconsistently. This leads to situations where you are prototyping and testing a solution. It seems to work fine with one assistive technology, then you start testing it with another, and things completely break apart. After a moment, you begin to feel like the Alice in the Wonderland. Things just don't make any sense. This is me right here. Anyway, there are some positive sides about this. For example, once you put accessibility into the mix, the Android and iOS platform are pretty much the same. This simplifies things. Throughout all of this, I've been reminded of a quote by Steve Jobs. Yes, he's more handsome than me. Great things are never done by one person in business. They are done by a team of people. Similarly, to achieve great accessibility, we cannot rely on just a single technique. We will need to find a combination of techniques that will work well together. Well, Have we found such a solution? I'm happy to tell you that indeed we have. We were able to design a solution that adapts and works very well with all the compatible combinations of these major technologies. The project itself is MIT licensed, open source, available at GitHub, where you will find more detailed project information, current documentation, and how you may integrate this into any of your projects, regardless of the technology you may be using. Thank you, and I wish you a nice stay here in Iceland.
And that's our first half of the lightning talks. We'll have a break for about 10 minutes and come back for more lightning talks later. Thank you. Sounds great.
Okay.
So which one? So I just want to make
One is the TPA one.
Oh, yeah. Hey everyone, welcome back to the second half of Lightning Talks. Our next talk is by Lawrence, and he's going to be talking about hacking the future. So here's Lawrence.
Thanks. Can I have a clicker?
I think it's this one.
Oh, okay, thanks. Hi, yeah, I'm Lawrence, and I'm actually a teacher at the University of Applied Sciences in Amsterdam. But that's not what I'm here to talk to you about today. I'm also a volunteer at a refugee code school called Hack Your Future. Well, I can tell you what Hack Your Future is, but it's actually been done better in this video. So I'll show you a short clip. There we go.
Hack Your Future is an initiative.
It's an organization that, especially for refugees,
that come to the Netherlands. I think it's mostly Syria, but it's from other places as well.
People who have left their countries involuntarily to pick up a new skill, hopefully.
So Hack Your Future teaches them computer programming, web development,
CSS and HTML, and you learn the basic about it, and then JavaScript, of course.
and helps them to find jobs.
These are people who had some unfortunate circumstances perhaps and are trying to do something good for themselves and for the world.
I'm proud of myself that I could learn it, although.
So this actually tells you a bit about what Hack Your Future is, but not so much about why Hack Your Future is. So Hack Your Future was founded by a couple of people who thought, well, there's a growing group of refugees coming to our country, and they'll actually have a lot of trouble entering the job market because they won't have the right background, they'll have some language barriers, maybe there's some discrimination issues going on. So how can we prevent these people from becoming marginalized in our society? So they funded Hack Your Future because they decided, well, what's the best way to actually empower people and the best way to get them jobs? Well, one of the best ways currently is to teach them web development skills, because there's a lot of demand for web development skills, and it allows you to go into various different paths, as you all know. So we thought, well, how can we do that? We came up with an idea of setting up a volunteer program where volunteers teach refugees every Sunday for about 4 hours. We have interactive sessions with them. And then they spend about 20 hours working on homework assignments, and they hand in their homework on GitHub, and we interact with them through Slack throughout the week. So they actually have some support for the whole week. We teach some basic skills. First we start off with HTML, CSS, because they have virtually no technical skills coming in, and that's like a really easy way to enter this field. And then we spent 9 weeks on the basics of programming through JavaScript, which I had a lot of pleasure in teaching them. They're super motivated, so it goes a lot faster actually than with my students at the university. And after, at the end of those 6 months, they work on a project and they actually develop something themselves. They often choose to develop something that will benefit other refugees, which is really awesome. Alongside that program, we also teach some seminars on how to conduct yourself in job interviews, how to make a good LinkedIn profile, well, you know, basic skills that you might also want, and things that are quite different in the Netherlands as opposed to, for instance, Syria. So yeah, that's the way that we set it up. So what have we achieved? Well, we have about 55 students that have found jobs at companies such as KPMG, Booking.com, and KLM. I guess that's the main thing that we've achieved. But we also have an active network of students, mentors, and alumni. There are 200 people strong. They're all in one Slack group. They help each other out with anything from finding good companies to apply at, to how to cycle through the snow in the Netherlands when winter comes. And we've also achieved 100% uptime for the past 2 years. And honestly, who can really say that about any program they're running? We also have some new chapters in Copenhagen, London, and Malmo. So people have started copying our project. And hopefully we've achieved part of, at least, a better future. So I also have a quote. It's not by Steve Jobs, it's by Jack, one of our students. He says that his main takeaways from the program were to how to think like a programmer, how to work in a team, and most importantly, that people can still treat him for the person that he is, and not the way that he might be seen, which I think is a very important thing for these students coming to us, because as soon as they enter our doors, they stop being a refugee and they start being a student, and we just treat them like that, and we don't really talk about their backgrounds at all. We just treat them as students, and we say, this is your homework, you have to deliver on it. We will be supportive and try to help you with any issue, but, well, you have to deliver. So actually, the point of this talk is not to tell you how awesome it is that I work at this program, that I volunteer, or how good this program is. I actually want all of you to start copying this idea and to set up a Hack Your Future of your own, because I think it's one of the best ways to empower people. So how can you do that? Well, you'll need a couple of ingredients. First off, a convenient location. It's important that people can actually reach your location, and a lot of these people will be in camps and they might not have a lot of money or means of transportation, so it's important that you find a good location. Secondly, you'll need some laptops. They don't need to be state-of-the-art. Actually, it's better if developers don't have state-of-the-art laptops, so they learn how to develop for all people. You'll need a program director, or better yet, a team of people who are prepared to think about the hard challenges that you might face to get everybody together. We can help you a bit with that. You'll need mentors, and this seems like it might be difficult to find people to volunteer, especially on a Sunday, as we do, but we've actually found that there's an abundance of mentors. People are really happy to help. There are people from universities, there's people from companies, there's people from, well, any place you can think of. A lot of people with diverse backgrounds like to help out as well. So we have a very diverse group of mentors helping out. And students, of course, this is the most important part. Might not be as easy as finding the mentors, because you need to find people that have basic English skills first. That's our minimum requirement. But we also want them to be very motivated. So we actually have them do a little test before they're allowed to join our program. And it's about learning a skill on your own. So they have to prove that they can do that within a certain amount of time. And it's a task that really anybody can complete as long as they're motivated. I guess a lot of people will ask, well, how do you get financial support? You don't need that much money. It's nice if some companies help out and donate old laptops. It's nice if the municipality helps out with the rent a bit or gets you a location. But ultimately, this is definitely something that you can overcome. You'd be surprised at how many people want to help if you have a good idea. Of course, you also need a curriculum. This is something that can be very difficult to set up, but we've already done it for you. So I'll show you a link on our curriculum. It's just something on GitHub. It's just a list of topics that we think is good to talk about, but of course you can set up your own way of doing it. So how would you do this? Well, just like JSConf, you can just say like, well, I think this is a great idea. I want to do this in my city. So I'm just going to basically fork the project, which you can do from GitHub Hack Your Future. And then if you want to know how to get started, you can just go to Start a Code School. And there will be lots of tips there. There will be lots of documents. There will be like a setup for a code of conduct. There will be an article about how to deal with students who have some trouble with staying in the country. There will be some tips on how to conduct yourself as a teacher. So we've tried to share all of the knowledge that we already have here. And we also have links to all of the resources that we use. If you need some more help, you can also talk to me on Slack. Actually, I think there should be a space between Lawrence and Arnoudse, which is a very Dutch name. But if you put that in, you should be able to find me, or you can just find me in real life. I'll be around for these 2 days. And I hope to work together with you into creating a better future. Thank you.
Thank you so much for that talk. I hope someone, or I don't know, maybe me, can bring that to New York. That would be awesome. Anyway, our next talk is from Christian. And he's going to be talking about something cool that GitHub can do.
Thank you. Hello. Oh my God, I can't see my speaker notes. That's fine. Hey, I'm Christian, and I work at GitHub, but this talk isn't like about me as an engineer at GitHub. It's more of a user. I have a clicker. So before I started working at GitHub, I would have all these kind of like ideas about like, I wish GitHub could do this one thing. And I would write these Chrome extensions to kind of help my workflow to do these things. But there's like some things that, oh, there they are. But there's some stuff that I couldn't do as Chrome extensions. And so for those things, I've recently discovered this library that, is this not the right clicker? It's this clicker. There you go. It's called Probot, and it's a library for GitHub to write these GitHub applications. And Probot does this by leveraging webhooks and the GitHub API to give you kind of the power to extend GitHub in a pretty simple way. And most instances of Probot are responding to events. So something happens on GitHub, Probot gets a ping through a webhook, and it'll like analyze like what should I do in this situation, and it will maybe fire off some events of its own. And we can actually I have a little trivial example, and let's say if we want to respond to every issue that's opened in a repository, and like let's just like say hello, just give them a little welcoming message. All right, we're going to build it right now. So we have this module, and it just takes in robot as argument or parameter. And so we can attach event listeners on the robot. And there's a list on the GitHub documentation page for the events you can listen for. And here we're just like listening for if there's any issue that's opened. We get this context with it. And so with this context, we can create a comment. This is kind of confusing. I didn't really understand this at first, but this essentially just gives you like an object back that operates in the context of this issue. And we just give it the body, thanks for the issue. And then just using GitHub API, if you ever used it, it's fairly simple. We just say, create this comment. and that's it. It's pretty easy. Like, we can run this, and every time somebody opens up an issue on a repository where this probot is installed, it will respond, thanks for the issue. I thought this was pretty cool when I saw it first, because you can do these crazy things. There's a bunch of probots out there. You might have seen them if you go into these popular GitHub repositories. Sometimes they'll like close down the issues when nobody has commented on it for some days. And I have a problem that I really wanted to solve with Probot. And it is related to ESLint. I don't know if everybody here uses ESLint, but I almost always use it in my projects. And I have it running, so like it will run in a build, and if someone broke an ESLint rule, it will give you like a red status on the pull request. There's just one problem with this. People can just like disable the rules right there in the code. And so this is a project that I have where somebody just disabled all the rules and just did whatever they wanted. Which is fine. Like, I understand that sometimes people just like need to get stuff done, and so they're like, I don't know how to do this. I know how to use jQuery show. I don't know how to like show and hide things. So I'm like empathetic to it, but I maybe would want it to like focus that you shouldn't do this, or like ping me and and I can explain them how they can do it correctly. So like this previous one, it just goes through, like everything's green, people are like, great, merge their pull request. Like I said, I would like for these to be flagged. So I wrote this probot that I gave it a little logo. It's just the ESLint logo with the eyes emoji. And so it just watches pull requests, and when a pull request comes in, it checks the diff, and if somebody added a ESLint disable, it will just comment right on there. Just please don't. There's a really great thing. You can, if you install probots into your repositories, you can give them configs. So my probot, you can change this message, and like if you wanna give them like a little image, you can do that. You can like at the team that should review this, be like at the JS team to be like, you can, you don't have to use jQuery show. You can do this thing. And yeah, if they're like legitimate ESLint disables. This talk went by really fast. You can find Probot on GitHub, probot.github.io, and my Probot is on my GitHub, which is up there. Thank you.
So that's actually all of our lightning talks for today. So I'm here to say that y'all can leave early. But I'm also here to promote the party happening at, I hope I can pronounce this right, Ayaskathur? I tried. It's in your leaflet. And also you can stay at Björnsloft leading up to the party, so until around 6:30. There's going to be a bus coming in from here and also the hotel to the party. And dinner is also provided, so don't, have dinner before the party, unless you want to have a second dinner, which, I won't judge. And Harpa opens tomorrow at 9, so hope you enjoyed, the rest of your day. Anyway, that's it.